Am I audible?
Hello. Am,
Hello?
am, am I audible, sir?
Yes, yes, you are audible. Can I also? I'm clearly audible, no? Professor audible? Professor Bhatt?
Yes, sir. Okay. So we will start now, maybe.
Oh, okay. So I am uh, just want to taste here whether the screen is. Can you recognize whether my screen is visible or not? Just I want to.
Yes, sir. Yes, your screen is very much available, or it is visible.
Now you see. Now you see whether my share screen is visible or not. You see just now share screen visible, na?
Yes, sir. Visible.
Okay, okay. Thank you very much. Thank you very much. Okay.
Okay. Good afternoon. Good afternoon, ladies and gentlemen. It is indeed a great pleasure and an opportunity for all of us to meet on this platform for this one-day international seminar webinar on recent trends in computer science and application, organized by Department of Computer Science of Raja NL Khan Women's College. I am Arup Das and I welcome all the academicians who have joined in from various parts of India and abroad. We organize such a program during this pandemic. We are very much fortunate to have eminent speakers who have joined us from various parts of India and USA also. So we know the technology is growing day by day. So we people are being benefited by that. In the midst of that, we are here to help our students who are interested in this area and others who are working hard in this area. And we may be able to give them the different views and on the different topics that are going to be discussed. So organizing an international webinar under the leadership of our principal madam, Dr. Joyashree Laha, was very encouraging. Now I request Honorable Principal Madam and also the chairperson of the webinar for her inaugural speech. I think she is available.
Actually,
May I request Principal Madam? Okay. Just a minute.
probably it was supposed to start at 2. It was early. That's why.
Okay. Okay. Maybe Madam is busy in some other works, so we can.
Hello.
Yes, Madam.
Hello. Hello.
Yes, Madam. Yes, Madam.
Ah.
Yes, Madam. Madam, please say some words regarding our webinar.
You already started?
Yes,
Already
yes, Madam.
started?
We have just started. We have just started.
Okay, okay.
We have just started. We are just waiting for you, Madam. Waiting for your inaugural speech,
Thank you.
Madam.
Okay, okay. Thank you. Thank you, Arup.
Yes, Madam.
A very good afternoon to everybody. I welcome all of you in the one-day international webinar on recent trends in computer science and application, organized by Department of Computer Science of Raja NL Khan Women's College Autonomous, popularly known as Gope College. Being the chairperson of this webinar, I have the opportunity to present before you the about the college, Raja Enil Khan Women's College, and the Department of Computer Science. Raja Enil Khan Women's College was established with the blessings and initiative of the then Chief Minister of West Bengal, Dr. Bidhan Chandra Roy, in the historical Gop Palace of Midnapur town in the year 1957. In years, the college has registered significant growth in the areas of teaching and research. The college has received A grade 3 times from NAAC accreditation. First in the year 2004, in 2011, and in 2016. The college has also received CPE. The college has received DFS funds twice. At present, college offers 27 subjects at the undergraduate level and 11 subjects at the postgraduate level. Last year, we have received 2 research centers, one for natural and applied sciences and the other for humanities and social sciences. Presently, we have 3,500 students and 155 faculty members. 40 research scholars are pursuing their PhD program under the research center. Just a minute. About the Department of Computer Science. Department of Computer Science has both UG and PG section. 2 batches of PG courses have completed their postgraduate studies. Every year, a good number of students from this department join renowned IT multinational companies like TCS, Wipro, Tata Mahindra, Capgemini, etc. Now, so it's growing fantastically, UG and PG sections of computer science. I really congratulate our teachers of this department. Now, this is the time to express my for the speaker, to welcome the speakers. I express my gratitude and gratefulness to all 4 speakers, namely Professor Jyotsna Kumar Mondol, University of Kalyani, Dr. Soumen Nandi, Professor, Institute of Engineering and Management, Kolkata, Dr. Shagnik Sen, Assistant Professor, IIT Dharwad, and last but not the least, Dr. Anabik Pal, Postdoctoral Fellow, Lister Hill National Center for Biomedical Communications, US National Library of Medicine, National Institute of Health, for their valuable time to spare with us as speaker. I welcome all of you to this webinar. I'm thankful to the Department of Computer Science for organizing this webinar. I wish all the success of this webinar, and namaskar, Jai Hind. Over to Arup.
Thank you very much, Principal Madam. Thank you for your valuable words that will inspire a lot. Okay, we are going to the next part is now I request Mrs. Deepanita Madam, HOD of Department of Computer Science, to enlighten about today's seminar. Deepanita Madam. Okay. Is Deepanita madam is available, madam? Madam, can you listen me?
Deepanita,
Okay.
Deepanita is not here. Aru?
Okay. We can go ahead. So our first speaker, Dr. Somen Nandi sir, is available. So sir is the professor of Institute and Management at Kolkata. He is also the visiting scientist in Advanced Computing and Microelectronics Unit, Indian Statistical Institute, Kolkata. So he has been also the faculty members of the Department of Computer Science and Information System of BITS Wailani, Hyderabad campus, and he received his PhD from in computer science from Indian Statistical Institute. Okay, now I welcome Sir Somen Nandi sir. Over to Dr. Somen Nandi.
Thank you very much to all of you, Honorable Principal Madam, and all the dignitaries. Special thank to Deepanita. Actually, she was my student initially when she was at Malda College, and I was there at that time. I am very proud and also privileged to be present in this platform. And 4 speakers are here. Actually, Professor Sainik Sen is my close collaborator in my research and is junior to me. And my teacher, Professor Jyotsna Kumar Mandal, we are used to say JKM sir. My pranam to Professor JKM sir. And my junior to ISI Kolkata, previously he was a research scholar at ISI Kolkata on a big pal. All of us are known to, all of us have joined here, and it is like a get together. Thanks for this platform, for getting together, all of you, with you. Right, and now probably I am audible, Professor Arup. I am clearly audible, no? I want to present the screen here.
Yes, sir.
Sir, pranam.
Please continue, sir.
Though I am a teacher, still in front of a teacher, telling something is difficult always. Okay.
No, sir. Please continue. We are very much fortunate to have you, sir.
Okay.
Please go ahead. Please go ahead.
Okay, sir. Thank you very much. The machine is a little bit slow. Why this slideshow is not coming here? Okay. So today's topic of discussion is an insight to randomized algorithm. First of all, I want to tell you why this topic has been chosen by me actually for this. Actually, the basic concept of randomization are not sufficiently broadcasted in academic education in the undergraduate level, what I feel actually. Though many successful applications of randomized algorithms are there, one of the main reasons probably what I feel that for the unpleasant circumstances in that reason, in that simple explanation and transparent presentations of these discoveries of this randomized algorithm or randomized computing are missing in the textbook, right? So actually the randomization has become a standard approach in algorithm design, very important algorithm design, that I will tell you through some examples that why this randomized algorithm is so important. Actually, efficiency and simplicity are the two main features of randomized algorithm by which we can solve complex problems in various applications. Like you can think of that there are applications in communications, cryptography, and we know several situations and algorithmic tasks for which any deterministic algorithm any deterministic approach leads to so much computing task that is impossible for practical problem. In that randomized method, you can solve that problem algorithmically with the help of randomized algorithm very efficiently, right? So that means you have to pay for saving a huge amount of computing time with a very small loss of degree of reliability. As randomized method, some probabilistic approach will be there. That means some degree of reliability. There may be some error, but if you believe on that degree of reliability, then with a very small loss, you can improve the efficiency for any randomized algorithm. So here the main question is, what is randomness and does there exist true randomness property? I will not go to the go through this type of questions, but here I can say rather that randomness is the source of efficiency for algorithm design. So our objective of this lecture is to show the randomized algorithm can be essentially more efficient than deterministic counterpart. This is our goal. Okay. Now see, what is all of you are knowing about the deterministic algorithm? What is deterministic algorithm? That is, one algorithm is there where some inputs are there and definitely some predetermined outputs will be there. Now, what is randomized algorithm? Randomized algorithm is definitely some input will be there. With that input, some random input will be there. Random input will be supplied to that algorithm, right? And then output will be generated. Then we have to concern about the outputs, whether the correct output will be generated by this randomized algorithm or not. That is the main concern of our these topics. Now you see, there are what I have covered here, two types of randomized algorithms. Two types of randomized algorithm, and for those two types of randomized algorithm, two parameters are the main important parameters. One is speed and another is accuracy. The first type is called the Monte Carlo algorithm, which can be probably correct, but the algorithm is very fast. That means algorithm is efficient but probably correct. That means there may be some error in generating the output. And second case is Las Vegas algorithm, that is probably fast, but we cannot guarantee the all time it will be fast, but it will give you always the correct output, right? These two types of algorithms will be covered in this lecture, and I will go through some examples, then it will be clear to all of you. Actually, I will be going through the details of this because of maximum of the what Dipandita said, the maximum of the attendees are the students. That's why I am going to the details about the examples. Okay. Now see, what is the Monte Carlo example? Now I am taking a real-time example. Suppose one computer is there in India and other computer is at USA. Now two databases will be there at India and USA, where the content are same actually. What is the application? Why those two same databases will be copied in two different places which are far away, India and USA? Because actually in the big data, in Google or Facebook data, so many same copy of databases will be kept in the several places because of some catastrophic failure may be there. But if you can save a 5 copy of those data, those huge data in 5 several places, then there is a very low probability, next to zero probability of getting a catastrophic failure of every locations, right? So same copy of the databases will be kept in India and USA, suppose for this example. Now, when you are developing algorithms and you are doing dynamically develop the databases, then in both the two places, the databases will be updated, definitely. But there is a protocol that after a certain interval of time, suppose every 6 months, they will check whether the two databases kept at India and USA are same or not. That will be checked. For instance, suppose X is equal to every database, actually what the data is stored in, it is in the binary form. Like this example you see here. This is X is equal to 1 on this one, X. So these two databases are not same. Suppose this is for the simple example. Now, so you have to check whether the two databases are same or not. How do you check this? You have to go through some algorithms. What is the simplest algorithm? That is, you have to send this n-bit data from India to USA, then compare those n-bit data to USA data. If both are equal, then you can say that those two databases are same. So there will be no headache. Otherwise, if those two are not equal, then you can say that those two databases are not same. So there may be some, there were maybe some error. So you have to take care of those things, right? Which one is correct, you have to decide. But here we are not concerned about which one is correct or not. But we are only concerned about the communication protocol. That means you have to send n number of bits from India to USA or USA to India, and then compare it. You cannot do less than n bits. Otherwise, there may be some errors. So this is the deterministic algorithm which will give you the correct output whether the two copies are same or not. Right? Is this equal to? That means, you see, what is the complexity with respect to the communication protocol? Complexity is as we have to transfer n bits and compare those n bits. So by deterministic algorithm, its complexity is big of n time. Okay. Now you see whether we can do better. There is no, actually we can say that there is no deterministic algorithm, it can be proved that which can be done better than big of n time, right? Now whether some random input will give you the efficient algorithm or not for this problem. Let's see the algorithm first. How simple the algorithm is to design a randomized computing. You see, as we are concerned about the n bits, and n is a huge number, because when we are talking about the Facebook database or Google database, this is a huge database. So, and n bit means it is a huge one. So choose a prime number uniformly at random from 2 to n square. Why I am taking n square, that I will tell you later on. Why it is not n cube, why it is not n. You will see later on. So 2 to n square, choose uniformly random a prime number p, right? Now construct, as x is basically x1, x2 dot dot x is a n-bit binary number, so it can be converted into a decimal number by this formula. All of you are knowing about this. Now find out a value sx, which is equal to this decimal number num x mod p. That means after dividing by p, which will be the remainder, that is basically sx. Now you see, send this sx and p to USA. That is, you are computing sx and p for India database. Now these two value will be sent to USA. Now see whether it is applicable here or not. Now compute, after sending this, compute num y, that is which is at that at USA database, num y, and also sy with respect to the same p chosen by you. That's why you are sending this prime number p, which is chosen at India level, right? Now you have calculated num y and sy. See, now what you can say, the algorithm is very simple, two-line algorithm. You see, if sx is equal to sy, then output will be x is equal to y, and if sx is not equal to sy, then output will be x not equal to y. Now my question is whether this is correct or not, and what is the complexity of this algorithm, because we are sending sx and p to USA, and as we are only concerned about the communication protocol. So you see here, for computing this num x from binary to decimal, there may be it will take maybe more time, but we are not concerned about this, because we are only concerned about the communication protocol. Why? Because that n-bit data, when you want to send, there may be some failure or maybe some conversion from 0 to 1 or 1 to 0 bits. So it will give you always an error because of the huge data size n. Now you see what is the complexity here. complexity is purely dependent on the size of Sx and size of P, because we have to send these two. Now we see, as Sx will be got from n modulo P, right? That means, see, always this is n square modulo P, so Sx less than equal to P less than equal to n square, because P is uniformly chosen at random from 2 to n square. So P less than equal to n square. Right. Now when those Sx will be converted into a binary bit, then how many bits will be needed? That is at most log n square, because this Sx value can be at most n square, right? So it is at most n square. And P is also at most n square, because every two Sx and P are both less than equal to n square. So total complexity will be, that means, will be 2 times log n square, that is 4 times log n. That means you have to send only 4 times log n bit data from India to USA. Now what is this value? Take for an example, if n is equal to 10 power 16, then complexity is less than equal to 256. If you put this in place of log n, 10 to the 16, you will get 256. That means only 256 bit data you have to send from India to USA, rather than those 10 to the power 16 bit. Actually 10 to the power 16 is much greater than 2 power 50. Actually it is a huge data size, but you have to send only 256 data. But the challenge is whether it is sufficient to send only 256 data to declare that your output, those two databases are same or not. That is the main concern. Let's see. So algorithm is very simple. So the complexity here, you see, complexity here is 4 log n. That means in terms of communication protocol, right? So what is the correctness? Correctness whether these two conditions given here, Sx is equal to Sy, x is equal to y, it will give you the same output or not. One thing is clear, that if Sx is not equal to Sy, that means you can confirm that output x is equal to y. Actually, what was x and y, it was definitely not equal if Sx not equal to Sy. But sometimes it may happen that Sx is equal to Sy, but actually x not equal to y, right? See, take an example. Let x is equal to 0, 1, 1, 1. Suppose this is a 5-bit data and y is equal to 5-bit data. And see, these two data, this is for India database, this is for USA database. You see, this x and y are not equal. Okay. So for 5 means we have to choose uniformly random a prime number p from 2 to 25, 5 square, 2 to n square. So how many prime numbers are there? You see 2, 3, 5, 7. These are the prime numbers. How many? Probably this is 9 prime numbers are there in between 2 to n square. Right. Now we see, now we are choosing p is equal to 7 here. Uniformly we have chosen p equal to 7. Now we see. So now x, if you convert this x into decimal form, it will give you 15, and this will also give you 22. Now if you do the mod operation here, for 15 it will give you Sx value 1 and Sy value also 1. Now what you will see, though x is not equal to y, but as we have chosen this prime number as 7 and do the mod operation, it will give you Sx and Sy as the same value. That means Sx and Sy, when those are equal, then you cannot declare that whether x is equal to y or not. But if x is not equal to if Sx is not equal to Sy, then definitely you can tell that x is not equal to y. Right. Now you see, thus the output will be x is equal to y, but actually it was not. Actually, both those two inputs x and y are not actually equal, so it will give you the wrong output. Right. Now, how about the other random inputs that we have chosen here? P is equal to 7. Now, if we choose except 7, you see, P not equal to 7 means other, either 2, 3, 5 or any other inputs. What we have observed here, that any P which is not equal to 7 here for this example, Sx is not equal to Sy. That means actually x was not equal to y, and if P is not equal to 7, then it will give you Sx is not equal to Sy. That means actually you see, you will get the correct output for every P except 7. That means 2, 3, 5, 11, 13, that all the prime numbers except 7s are the good prime and 7 is the bad prime. Why? Because for me, it is a bad prime because it will give you the wrong output. But all other primes will give you the correct output. But here what you observed, what we observed that the maximum prime numbers will give you the correct output and only a few prime number will give you the incorrect output. But this is for a particular example. Whether you can prove for any n, then it will be a good algorithm for everyone, right? Now we want to prove this for general. You see, so probability, that means probability of correctness is very high here. That is the observation from an example, right? So we have to find out the error probability. What is error probability means? If you find out the bad prime and number of bad prime by the total number of primes will give you the error probability. Very simple thing. That is class 11, 12 level probability. So you see that now if we can find out the number of bad prime is very less than the total number of primes, then we are done. Now see, suppose prime n square is the set of all primes in between 2 to n square, and this is the set of bad primes and this is the set of good primes. This is the notation. Now what is the error probability? Cardinality of bad prime by total number of prime numbers. Okay, this is the error probability. Now what is the objective? So if I can show that error probability is very less, that means our algorithm almost will do the correct work. That is, almost all the cases will give you the correct result, correct output. Otherwise, if you cannot prove that error probability is not much less, then sometimes you will get a correct output. Sometimes I will get an incorrect output. That means your designed algorithm is not reliable also. So you have to justify your algorithm whether it is a good or not. With the help of this.
Sir, I have a question just.
Yes.
Sorry to interrupt, but bad prime you have given the probability of x and y. Can you define what is x and y? And in the error x and y, you have given prime n square. Like, what is that? I just wanted to ask.
Oh, a prime n square is the set of primes in between 2 to n square, right? And bad prime are those primes. Now you see the previous slide, then it will be clear.
So, no, what is x and y?
X is the input. It is stored in the database in India, and y is the input stored in the database at USA. Now we want to compare x and y. Those two databases are same or not? Is it clear?
Yes, sir. That is a like marginal probability, or like what are you saying, a joint probability, that kind of.
No, the simple probability. I am doing the simple probability calculation. I am taking the simple example here. Simple means with number of bad prime. If you can find out the number of bad prime, you know the total number of prime numbers. So error probability is number of bad prime by the total number of prime numbers. Right.
Okay.
This is for this example. So
okay.
For this example, we are doing this, right?
Yes, sir.
So number of bad. So many examples are there. They are mean cut, randomized mean cut theorem, and they are independent conditional probability. Everything will be taken care of in that cases. Actually, we are taking the here for the simple examples. As everyone, maximum the undergrad students. That's why I am taking. Okay. So you see, error probability is number of bad prime by total number of prime numbers. You see, our claim is the bad prime, total number of bad prime is less than equal to n minus 1. That is our claim. Why I am claiming this? That you will see later on. It will give you the less error probability. That's why I am doing. If it is less than equal to n minus 1, then we are done. Now see, the proof of bad prime for this xy is less than equal to n minus 1. And P is chosen from that set of primes, right? Uniformly at random, and it will give you output x not equal to y, but sx is equal to sy. That is, it will give you the incorrect output. That's why it is a bad prime. The condition for bad prime is x not equal to y and s is equal to y. And say W is equal to num x minus num y. That is the absolute value is equal to kp. Now you see, as sx is equal to sy, that means those two numbers x and y are in the same equivalence class. So the difference will be definitely a multiple of p, and that is written as kp. Now you see, thus p, if the p is a bad prime, thus p is a bad prime if p is a divisor of w. From here we can get here. Now see, observe that w is less than 2 power n. Why? Because actually num x, when you have generated this num x as a decimal number from that n bit binary number, binary sequence, the highest weight was 2 power n minus 1. So maximum value is at most 2 power n. As we are taking the differences, so it is maximum 2 power n. Hello. Now, so W can be expressed as, with the help of prime factorization theorem, especially P1 to the power of A1 Pk to the power of Ak. This is a prime factorization method where P1, P2, Pk are the prime numbers, and these are the hours, means how many times the primes are occurrence of those prime numbers. Now, if k less than equal to n minus 1, that means prime factors are, number of prime factors are less than equal to n minus 1, then we are done, because this is coming from this this condition when p is a bad prime, if p is divisible by w. Now see, that means every prime number is a divisor of w here by prime factorization method. Now see, if k greater than n minus 1, then this w can be greater than or equal to p1, p2 pn. Very simple. Power will be taken as 1, and that is definitely greater than or equal to factorial n and greater than 2 power n, which is basically a contradiction, because w cannot be greater than 2 power n. It was actually less than 2 power n. So k cannot be greater than n minus 1. So what we have seen here, that p is a, p is a bad prime if p is divisible by w, and maximum of n minus 1 distinct factors will be there, which can be a bad prime. So the cardinality of bad prime is at most n minus 1. Right. Now see that what is the error probability calculation. Now the claim is correct. Bad prime is less than or equal to n minus 1. Now one important famous number theorem is there, that is cardinality of prime n. Prime m means m set, that is 2 to m, all the prime numbers cardinality greater than m by log n m for m greater than 67. That is a famous theorem. I will not go through the proof. And limit n, m tends to infinite, it will give you actually 1 actually. But it is slightly, it will slightly greater than this one. And when you replace m by n square, here for our case it is n square. When n square, then it will give you n square. It was 67 means n greater than 8 by number. Now we see there. Now what is the error probability? You can put here that error probability less than equal to, bad prime is less than equal to n minus 1. So you can put here n minus 1. That's why it is less than equal to. And this cardinality, as it is below in the denominator, so it is greater than means it can be put in the below. And n minus 1 can be taken as n. So you will get ln n square by n for n greater than 8. You will get this error probability. Now you see what is the behavior of this error probability. Now why? Now are you getting my point? Because why we have chosen this 2 to n square? Because there is a theorem number. It is coming from the number theorem that if it is prime n square, then it is n square by ln square. If it is n cube, then it will be actually slightly increased. Then it will give you the best output, right? Now you see, when n is equal to 10 power 16. With this data, what we have taken in the very first thing, so 16, then the error probability is 0.36892 and 10 to the power of minus 14. That is a very less number. So error probability is very less actually. Clear for this one? You see, at least this is a good algorithm. And we decrease the error probability. Why we are trying to decrease the error probability? Because there may be some pessimists who are not satisfied with this error probability and wants to have an error probability below all physical level. So for those pessimists, whether we can decrease the error probability by designing in another way, we'll see this. The protocol is same here. The modified algorithm here, you see, we are using the independent property of the probability here, you see. Rather, we are choosing the 10 prime numbers uniformly at random among those prime numbers in between 2 and n square. And correspondingly, you see, for every pi, we have to generate all si value, and we have to send 10 pis and 10 sis. So for that example, you can remember only 256 data you have to send, rather 10 to the power of 16. So here, how many data you have to send? 256 into 10, that is 2560. That is not a large number. That is a very less number. That means you can send this 2560 bit number from India to USA. Still, it is manageable, right? Now, what is the complexity? As chosen, all those prime numbers are independent, so the complexity will be multiplied, and the complexity is 10 times this one. So error probability will be ln n square by n whole to the power of 10. It should be multiplied because this probability is independent. Now, what is the output here? You see, for 10 n equal to 10 power 16, the probability here is error probability is 10 power minus 141. That is very, very less amount. That means you can say that this error is nothing. That means almost all the time, this algorithm, the second modified algorithm, will give you the correct output for this checking whether the database value x and y are same or not, right? It was previously 10 to the power of minus 14. So it is the good algorithm. You can do in place of 10 times, you can do, if you are not satisfied, you can do 20 times, then it will be 20 times multiplied, then it will be much larger than that one. That means as you wish, when you will be satisfied, you can do this, but till there is a trade-off for sending the data. How much data maximum you can send so that there will be no failure in communication, right? Because if the large amount of data you want to send, then it will take time, and there in between that there may be some failure. And another advantage is when you want to send n bit data from India to USA, then actually n bit extra space will be needed for that USA, right? So also space complexity will be increased. But here, when only a few number of bits will be sent, then you don't bother about the space complexity, right? So there are the two advantages, but there is a small, very small risk here to get the incorrect output. Almost all the cases will get the right output. So this algorithm behavior is nice. Now is what we have observed here. This is actually Monte Carlo algorithm. Now it is clear that the algorithm is probably correct. That means max in almost all the cases it will give you the correct output. There are a few cases where you cannot, but it is guaranteed that the algorithm is very fast. That's why it is called the Monte Carlo algorithm. It's called Monte Carlo, and there is another algorithm, that is Las Vegas algorithm, that is already probably known to you. I'm taking the example of Quicksort algorithm. It is known to all of us, all of the students. And this worst case complexity, when we are choosing the fixed pivot element as the first element, any fixed pivot, it is order of n square, right? And if you select the random pivot element, then expected complexity is big of n log n. Actually, here there are two things. We can design the deterministic algorithm for Quicksort, and our analysis is expected case. That also we can generate a randomized algorithm, like choosing the random pivot element. That is all the n element input will be there, with a random pivot input will be there. That's why it is randomized algorithm. And then expected time complexity is big of n log n. That means it will ultimately, the output will be correct, means it will give you the ascending order list. Output is always correct, but you cannot guarantee with the time complexity. There are few cases where the time complexity in big of n square. So this Las Vegas type of algorithm, we call this probably first means there are some cases where it will go slow, but it will give you always the correct output. And there are some methods which is called the Atlanta algorithms. We are not choosing here. So these are the two randomized algorithms I've discussed here. Now, at last, I want to tell that what we have learned here, the randomized algorithm is far better than the deterministic algorithm. Theoretically, always the randomized algorithm, deterministic algorithm will give you the correct output, and randomized algorithm may give you some error. And during runtime of on a computer, a hardware error may occur and produce some wrong outputs, right? So probability of occurrence of a hardware failure is directly proportional to the running time of the algorithm. So if that means a randomized algorithm computes a result in 10 seconds with the probability suppose 10 to the power of minus 30, then it is more reliable than a deterministic algorithm whose computational time is 1 week. That I believe actually. Okay, so this is all about this randomized algorithm. Thank you, and this is my mail ID. Thank you once again.
Thank you, sir. Somen sir, thank you for your valuable insight. I hope all of us have achieved some new concepts that will definitely help us in future. Okay, we will take some questions. So
Yes.
we are expecting some questions from students and all the participants who are available. We are waiting for questions.
Okay.
Or any doubts or any questions that are available or
Always welcome. If you have any questions, please ask me.
okay, sir. Sir, regarding the Monte Carlo time complexity,
Yes.
So how it is far better than other randomized algorithm?
No, actually, Monte Carlo is such type of algorithm design, randomized algorithm design technique, where the algorithm will give you probably correct result, but it will give you the guarantee of the efficiency in terms of time. Actually, those are called Monte Carlo algorithms, right?
Okay, sir.
Okay. Actually, this type of algorithms, and there is this type of algorithms are mostly used in Google, Amazon for this one. When there are for deterministic algorithms whose complexity is very high, till it is polynomial. You see, you have to send only n bit data from India to USA or USA to India. But if n is very large, in practical scenario, actually n means is it not a linear. If n is a huge number, then if you want to send this n bit from one place to another, which are far apart from them, then it is a great headache for them in terms of space complexity, also in terms of communication protocol. So if I can so that is what we have learned here. The randomized algorithm is always very simple to write and simple to execute, but you have to justify with the help of mathematics. So for designing this type of algorithm, much more insight in mathematics needed, maximum probability and also number theoretic results will be needed for doing this randomized research.
Yes, yes.
Any more questions, please?
Okay. We are waiting for our participants. If they have any kind of questions, please ask. You can write it at YouTube chat box or Google Meet chat box.
So we are using Monte Carlo algorithms, but there is always a chance that the data can be corrupted. So like there is any recovery process.
And I don't know what is the recovery process there, but we are actually here concerned about the correct result, correct output or incorrect output. Actually, in this algorithm, it will not take care about the recovery things, right?
Yes, sir.
It is taken care of by other things.
Okay, like there is a huge amount of data. Some data might be corrupted, like we are changing a bit and then the whole data changes. There can be
Right.
some instance that also.
That's right. That means that I want to tell you that when you are sending NB data from India to USA and you want the simple algorithm, you have to compare those NB data from India to USA. You have to compare. So by that at the time of communication, there may be some corruption. Though there may be some corrupted data if you want to send, because packet by packet it is sending. And there may be some hacking those data. So that error can be taken care of by sending the smaller number of bits from India to USA or USA to you can.
So no, sir. I'm just asking about like for this algorithm, there in the Monte Carlo algorithm, there is a chance that like there can be repetition. Like even if we're using very large prime numbers, there is still a chance of repetition. So, can there be any process to safeguard this kind of chances? Like,
Oh, uniformly at random. When you are telling about the last modified algorithm when we are choosing 10 prime numbers.
Yes, sir.
When choosing 10 prime numbers, you are telling that there may be the cases that two prime numbers are same, right?
The result might be same for two numbers. I'm saying that.
Definitely, but error probability increased. You see, if there it can be handled by actually nothing.
Yes, the probability decreased very much, but like we always say, like there is a probability. I'm just saying that. I just don't want to extend the talk very much, but I'm just asking.
Okay, but it can be handled when actually everything is pseudo random. When one random prime number will be chosen, you can ensure that that number cannot be chosen further. You can ensure that by writing a pseudo random number generator, right?
Okay.
It can be
like Martian. We got it, sir.
Right. It can be.
Any question from any other participants? We have still few minutes. So if anyone has any questions, so please write it at chat box, or you can send messages, or you can comment in YouTube also.
Feel free to ask me any questions, please.
Yes, definitely.
Students, I want students to ask me questions about this one. Actually, I want that professor like JKM sir, sir is in the various committees. If this randomized algorithm can be written in a lucid way so that undergrad students can understand, and it should be included in the undergrad's level in the syllabus. JKM sir can take care of these things. Not the complicated things actually. This is still now it is a research topics, and
Yes.
In some places only. And when I was at BITS Pilani, Hyderabad, then at MTech level, though MTech level it was there also BTech, and this is an optional course, and BTech students can also opt these courses.
Okay, I think participants have already understood many things, so they are not asking any questions. So thank you, sir. Once again, thank you for your valuable time and giving us some valuable insights of a new topic that is very much research oriented problem, and people are very much interested in this domain. Thank you once again, sir.
Thank you very much to all of you. And thanks to the organizer of Gope College. I used to know as the Gope College. Emil Khan Kolvedar is famous as Gope College. Thank you very much, Mr.
Thank you, sir. Welcome.
I'm here to listen to the next speaker and also JKM sir.
Okay, sir. Okay, our next speaker is Dr. Sagnik Sen. So let me check whether sir is available or not. So please have patience for a minute or a couple of minutes. So
Yes,
that,
sir, I'm there.
Okay, sir. Are you available, sir? Okay, sir. So
I'm available,
sir,
but the thing is, the thing is that we have some half an hour time left before my talk, right? Because if someone has planned to attend that, they will come after half an hour. So I don't want to be unfair. So what I was proposing, fortunately or unfortunately, we have some spare time. So what I was proposing, if Shomendra is available, are you available, Shomendra, now?
Yes.
Or you have to go somewhere?
No.
Available. So if you agree,
Yes.
we can have some other kind of interaction with the students.
Okay.
In this half an hour, because my talk starts at, according to the brochure, it starts at 3:20. So we can have some interaction with the students, because if some student have planned, it's an online thing, no? So if someone has planned that I will attend at 3:20, then that person will not be able to attend.
Better.
That is why. So if you are
okay, sir. Okay.
So is it okay, organizers? Is it okay?
Yes, sir. Somen sir, if you extend your talk for half an hour more, so that will be very beneficial for us, sir. Please.
No, we
continue.
will not extend, but we will discuss something else with the students. Let's see, something funny
Okay,
maybe.
Yes, that is
Something
also
that they can also enjoy. I have something. Let's see. So let me turn on my video. So it's a bit of a. I am not in my natural setup, so I came to Calcutta. It was not planned before. So when you asked me for the seminar, I was actually not planning to come to Calcutta, but I am in my in-laws' house now. So there may be some external noise. So am I audible properly? There may be some network issues also.
Yes,
students,
sir.
some rest of you will be nice.
You are audible, sir, properly.
No, but some other ones.
You're audible,
okay,
sir.
Thank you. Right. And how about others? Some 5-6 people, because Shomendra spoke about statistics now, probability. So if only out of 43, 2 people answers, that means there is a huge error probability. So maybe people can answer. You can write in the chat box also. It's fine. This is very informal. I didn't start my talk. I start at 3:20. So if you want, you can go and come back, or we can chat for some time just like that. So someone in the chat box, can you please say? Maybe I see some names. Okay. Jyoti Malik, Payal Datta. Yes. And someone else? Or anything. Okay. Let me ask you some question. Okay. Kalpana, Joita, Payal. Thank you. Yeah, now you see, now we also know, like in Shomendra's case, that there is a high probability that I am audible to everyone. Okay. And I am definitely audible to 8-9 people, whoever has told anything. So this is a good practice, because during my talk, I would like to be interactive. Unfortunately, for this COVID situation and all, we are not able to be present, physically on stage or something. Then it is easier to in a classroom or something, then it is easier to interact. But anyways, now let me ask you some question. Let me see. Let me maybe I will share something. Let's see. So okay, let me just ask you something. So who from which standard are you guys from? You are UG students or PG students? For example, let me go one by one. Jyoti Malik, you are from, what are you doing now, Jyoti? If you can write in the chat box or you can speak out as you wish. BSc CS. Okay, great. And then who is, okay, Moushumi already told, she is from UG. And Payal Datta and Payal Adok, Kalpana, Joita, Santa, Oritro.
So most of them are
What are you doing
from
now?
UG Computer Science and UG BCA students.
Any BCA students? Because Dipannita was telling me that BCA, there will be some BCA students also. Okay,
Yes,
Payal Datta is doing BSc honors. Most of you are BSc. Okay, great. So let me see. Let me ask a question. Okay. So suppose me and Shomenda, we or let's say there are twins. So say there are two people. Okay, they are twin brothers. Okay, one of them always speaks the truth. The other person always speaks or always speaks lie. So I will say there are two brothers. One always speaks the truth. The other always speaks lie. Tells lie. Okay. So this is the scenario. Now I'm going to show Menda's probability again. Suppose you randomly choose one of the brothers. Okay. And ask, is your brother truthful? What is the probability of getting the answer no? So this is my question. Any answer is, whatever probability you say is fine. Just write it in the chat box. So there are two brothers. One always is saying telling the. Okay, Kalpana says half. Why? Why? Can you explain why? Kalpana, you may use your headphone or speaker also, or you may give me some hint in the chat box. I will help you to explain. Jyoti also says half. One of you, can you please tell is half?
There are total number of options are only 2.
Sir, can I say it's like
So,
1?
Sir, total number of options 2 and the probability
who says
of getting
1?
Sir, I didn't know.
But total options is 2. See, you have chosen, first you have chosen randomly which brother, right? And then there is an answer. Okay, many people are saying half. And someone said 1 in the middle, right? Someone said 1.
Yes, sir, I said that.
Yeah, why? Diptendu, you have some
Sir,
reason?
Sir, I thought that if you're choosing the truthful brother and asking like, is your brother
Okay.
like lying, and then he will always be saying yes. That is
No, but the question, remember
for
the
one
question.
part that
The
is zero.
question is your brother truthful? The question is not, is your brother a liar?
Okay, I got it.
So
That will
what
be,
you are doing is good. Then what will be the
so that
probability?
will be zero. That will be zero.
0. Excellent. Good. So very nice, Diptendu. A clap for you. So that is the correct answer. So you see, others also, what you thought is not very wrong, because you have two options you are thinking, and then one option will be true. But that's not the case. It's not actually a probability question at all. It's a trick. It's a trick question. So you see, suppose I am the truthful brother, and you ask me, is your brother truthful? What will I say? I always speak the truth. My brother is a liar, right? So I will say no. Okay. Oh, okay. So Diptendu, I think your first answer was correct, but your reasoning is correct. That I am sure. Let's see. So if I am truthful, if you ask me, is your brother truthful? I will look at my brother. He's a liar, so I will say no. If I am a liar, okay, then if you ask me, is your brother truthful? My brother is truthful. So if I say no, then I am actually giving a correct answer. But then I am a liar, so I will again say no. I will not say yes. Because if my brother actually is truthful, does that make sense? Kalpana, is it fine? Jyoti, Payal, is it fine? See, no matter who I am, who you choose, right? Even if you choose the truthful brother, my answer will be no. Even if you choose the liar brother, then also my answer will be no. Okay, in both cases it will be no. So the probability is actually 1. Yeah, sorry Diptendu, I changed your answer, but what you are saying initially is correct. But anyway, your reasoning was completely
No
correct.
problem.
That whoever I ask, the answer remains no. Okay. Okay. So we have few more time. Now let me in fact test my presentation. Okay. And then I can draw something there. So I will present, and by that time I will switch off the video. Or maybe I'll do another thing. Just a second. So I want to have this chat box side by side. Arup, are you one of the organizers?
Yes, sir. Yes, sir.
Okay, okay. So what I will do, I will log in from another ID also from my cell phone.
Okay.
And from there, I will follow the chat because I want to communicate with the chat. And then from my laptop, I will, okay. Maybe I will do this YouTube live. Okay, so you don't need to give me any permission or anything. I will go to YouTube live. But is the YouTube live delayed or the same time?
No, it is real time, sir.
Maybe it is a bit delayed. No, I think usually YouTube live is 5-second delayed. Usually.
Maybe. Okay, sir. You can log in at in different ID,
Yeah,
and
I did. Yeah, I did. I already did. So can some of you write something so that I see that I can follow the messages or not? One of you can. In fact, I can write something. I can say hi to myself. Great. And I can say hello to myself again from the other one. So great. So both are my IDs. The first hi and the second hello. Okay, great. So from my cell phone, I can follow the chat. And here I will actually switch off the video so that you can see the presentation. Okay. Okay. There will be some ambient knowledge. I'm in Mudhamgram, so you will hear probably frequently flights going on. Okay, so this is the second question, second riddle. Okay. So can you see my screen? Is my screen visible?
Yes, sir. This is
You
visible.
can tell me in the chat. Okay, okay, great. Okay, thank you. Now, there are 3 boxes, okay? Maybe I'll change the color. Just a second. Right. There are 3 boxes. One of the boxes has red balls inside it. One of them have blue balls inside it. One of them have mixed. Now, your clue is all these labels, they are wrong. All labels are wrong. So this label says that it is red, but it is not red. It is something else, either blue or mixed. This label says it is blue, but it is either red or mixed. This label says it is mixed. It may be something like red or blue. Now what you have to do is, you will tell me one box among these 3. You can choose only one box, whoever plays this game. If you choose this box, blue, then you will tell me, I want to pick something from the blue box. You cannot see what is inside. So I will pick up a ball from this box and tell you the color. Based on that, you have to correct all the labels. Okay. So who wants to go first? In the chat, please mention.
Sir, you please repeat the last statement you made.
Yeah. So you will pick one ball from one of these boxes. You choose one of these boxes and pick one ball. I'll tell you the color of the ball. And now you have to fix all the labels. So these are all wrong labels now. You have to make it correct. Okay. You once you start playing, you'll know. So who wants to play? Tell me in the chat box. Whoever wants to play. Whoever types first gets a chance. No, don't be shy, please. Please, you don't have to understand the game. You will understand it while playing. Yes, someone raised hand, right? Okay. So who raised hand? Kalpana. So Kalpana gets the first chance. Second is Diptendu. So tell me, Kalpana, from which box do you want to pick up a ball? Which box do you choose? Blue. Okay. So let me tell you, from the blue box, when you pick up a ball, the color is red. The ball you get, the color is red. Now, can you fix the colors of all the boxes? Fix the labels of all the boxes? Can you tell me what color is this box? For example, this particular box. See, it's not blue. You can turn on your mic because that will save some time. If you do not have a problem, then you can chat. Yeah, so it's red or mixed. So what Kalpana is saying, so you see, Kalpana is playing, but you guys can play parallelly and answer. So this one, if it is a red, see, because it's not blue, but now it can be red or mixed. So your choice is not so good, I would say. So maybe now, who was there? Diptendu can make a better choice. Diptendu, can you choose some other box?
Sir, can we choose mixed actually? Because like if we
Mixed.
choose mixed,
Okay,
we
great. Let's see.
We'll get-
Diptendu, you have chosen mixed. I'm telling you, the color of the ball is blue that you get from here. Now, can you tell me something? That
yes, the
what is
mixed
the-
is blue. The mixed
Okay,
and the mixed
so you
container is
see
blue.
this, what Diptendu is saying. Wait, let me explain for everyone also. So you see this container had mixed label on it, but all labels are wrong. So this cannot be mixed. This could be red or blue, but if it was red, it was not possible to pick a blue ball from this box. So this is definitely not red. The correct label of this box must be blue.
So
So
can
I
I say
will
next?
write it. This will be blue. Okay. But if this is blue,
Sir, red will be
then-
mixed and
why? Because you see, the red cannot be red. It cannot be blue also, because blue is already taken. Blue is here. So the only option for red is to be mixed. And then how about this one? This cannot be blue. Mixed and blue are taken. So Diptendu, what will this be? I've actually written it.
red.
Yeah, good. So Megha also got this. Good. Megha got it. Megha Mohapatra, she also got it while chat in the chat box. She wrote it. Okay, that's very nice. So these were two riddles that I wanted to ask you. Let me now turn on the video again. Okay, Kalpana also got it now. That's nice. Okay, thank you. So we have some time. Maybe I will ask you another question and I will take a break for 2-3 minutes just before the talk. Just drinking water or something. But let me use the board again. And you know, there will be some questions, similar kind of questions in my talk also. But it will be a bit more involved than this. Okay. So I have a row . I have a row. Now this one will take some time. Okay. Okay, I need 2 volunteers. 2 new volunteers. Please raise your hand or mention in the chat box who wants to play. No one? You'll play against each other, not against me.
If no one will be coming, then I want to play.
Okay, Great. Who is this? Diptendu?
No, sir, it's Showman, sir.
Yes, Diptendu, please join.
Oh,
Yes,
okay,
sir.
okay.
I am always, sir.
No, he's always there. I said some new volunteers. Why not Megha? Megha, are you interested in playing? You give an answer. If so, please say. You don't have to speak. You can chat also. So in one side, okay. Let me take Showman. Showman, are you there?
Yes, yes.
Okay. Thank you, Showman. But I cannot make you guarantee a win for you. I don't know that.
I want to play.
Okay, now Megha
I
says
just
yes.
win.
Okay, so Megha, the next one you will be there. Okay,
Okay.
I'll ask you for the next one. So Diptendu, you
Yes, sir.
choose a number, some integer, positive, natural number. Let's say natural number. 0 is not there. Okay, 1, 2, 3, 4,
Sir.
whatever. You no, but don't tell me the number. You just think about the number. Okay. You thought of it?
Yes, sir.
Did you think?
Yes,
Yeah.
sir.
Now, Shomenda, please think of a number. Don't tell anyone. You just think of a number.
Yes. Yes.
You thought? Okay, great. Now, my question to Diptendu is your number bigger, greater than equal to Shomenda's number? You can answer with yes, no, or I don't know. I can't tell. You have 3 options.
I don't know.
You don't know. Shomenda, is your number greater than or equal to Diptendu's number?
I don't know.
Okay. I will again come back to Diptendu. Just let the plane pass. I'll again come back to Diptendu and ask, is your number greater than equal to Shomenda's number? What is your
Is this
answer?
a game theory?
Sorry?
No, I don't know. No, sir. I
Okay.
don't know.
So if I keep on doing this, keep on asking you the same questions, will you always be saying I don't know? Or at some point of time, one of you will say yes or no, something like that.
Now,
Someone will take a guess.
I think for that case, we have to be intelligent enough.
Yeah, I'm assuming all are very intelligent. That is true.
Yes, that means we have to answer logically that why I am telling I don't know.
See, a very interesting thing is happening here. I'm asking the same question to you, but suppose, just suppose that Diptendu had chosen the number 1. Now, if I ask this question, is your number greater than equal to Shomenda's number? I'm writing like this. So D is Diptendu's number and Shomen's number is SO. So if I ask this question,
And is there any
had
boundness
Diptendu
of
chosen
this
1,
number?
what will be the answer?
Shagnik,
Yes, there is a question, please.
Professor Arup is asking something.
Sir, is there
Yes,
a
please.
boundless? Is there a boundless
No,
of this number?
it's not bounded. It can be anything. It can be anything. But I'm saying, just think of the scenario. If had Diptendu, I don't know what his number is, had Diptendu chosen 1, and I have asked him, there is a lower bound. So bounded means there is no upper bound. It's starting from 1. 1, 2, 3, 4, all the natural numbers. So had Diptendu chosen 1 and I had asked him this question, what will be his answer? He will immediately say yes, because he knows.
Yes.
Sorry. Did I say greater than equal? No. Then my question is wrong. So I should have asked you less than equal to. Extremely sorry. So my question would be less than equal. If I ask Diptendu, is your number less than equal to Shomen's number? Had Diptendu, no, greater than equal to is also okay, no? Because you can say no in that case. So,
Yes.
okay, question stands corrected. Had I asked this, then Diptendu's answer will be, okay, then it is not greater than equal to, it will be strictly greater. Greater than equal to will also work, but I have to go another iteration. Let's not do that. It will be simply greater. Then Diptendu will say no. As he said, I do not know, that means Diptendu's number is not 1. Similarly, if Showman had chosen 2 and answered I don't know, because he already knows from Diptendu's answer that Diptendu's number is not 1, so it is at least 2. Then Showman's number is not 2. Next time when I ask Diptendu, if he says that my number is not, I don't know, then his number is not 3, and so on. So options will get eliminated. If Diptendu had chosen 10, then after 10 steps, he will say yes or no, depending on the question. Think about it. Think about it in your home. This is not the main topic. Okay. I'll just take a 1-minute break and I will come back with my slides. So maybe I can start sharing my slides. Sorry. Okay. So I'll come back in 2 minutes. Okay. By the way, I will need some volunteers. So you can choose among yourselves who wants to be volunteer. So you can write in the chat box if you want to be a volunteer. You can repeat because Kalpana, Diptendu, you can repeat also, no problem. So, but you don't know for what it is. It will be something similar. So it's something fun. There is no right answer, wrong answer, nothing like that. We'll just have some fun. Okay. So please choose. Please keep the chat box running. Whoever wants to be volunteer, please list it here. I will go one by one. Okay. I'll come back in a minute. Thank you. Okay. So if you have some formalities, you may do it.
Yes, yes, sir. Those are, sir, you have started much earlier, but for the students who don't know you, for them, I will introduce about yourself.
Sure, sure.
Sir, Dr. Sagnik Sen. So he is an assistant professor of Department of Mathematics, IIT Dharwad, Karnataka. So he did postdocs from ISI Kolkata, ISI Bangalore, and Indian Institute of Science Bangalore also. He did his PhD from University of Bordeaux, France. And please, sir, continue, please. And
Yeah.
now I welcome to you, sir, and over to Dr. Sagnik, sir.
Sure, sure. Thanks a lot, Arun, for the nice introduction. Now, let's see. Is this just a second? Yeah, it's okay. Right. Okay, so as you know, my title of the talk. Oh, I didn't present my screen yet. No, I will turn off the video. Whoever was present before probably is a bit familiar with the ways I am going. So please, I would love if you guys are responsive over the chat. I have a separate device for the chat. Now, this is my talk. You see the title. I don't know. I mean, this title is a bit strange, actually. We don't see it very often in seminars or something. But trust me, it's not a biology or any talk. It is a graph theory talk. But yes, as Kalpana asked, that if there will be fun, I hope. At least for me, it's quite enjoyable. Hopefully for you guys also, it will be. So do you know what is a Brussels sprout? So Brussels is a place in. So Brussels is in Belgium, okay, and there are some things. It's a bigger version of chola bhaja, as you can call it. So I'll show you the picture. It's green in color, and it's very small. You can fry it, you can boil it, and you can eat it. It's a popular food. But my talk has nothing to do with these sprouts. Okay? No, it's not bandhagopi. It's not bandhagopi. It looks like that. It's very small. So this one piece is like a little bigger than a cashew or almond.
Right.
It's a kaju badam. It's like a few 1-2 centimeters maybe maximum.
Mm-hmm.
Now the thing is, for me, Brussels sprouts is something else. Oh, I'm sorry. It's very noisy outside. It's from my some hawker is home. Sorry about that. But anyways, let's see. For me, I will draw those Brussels sprouts like a cross. So I will just draw a cross here. Okay. And or maybe I will, instead of cross, I will make it a plus because of some reason. So I will make the first plus will be A, and then another plus maybe B. Let me see. But first volunteer is Kalpana. Kalpana, if you can switch on your mic, then it will be faster. Otherwise also, if you are not comfortable, we can chat and then it will be okay. So if you can switch on your mic, then it will be easier for you.
Yes, sir. Yes, sir.
Okay. So you see this A and B, there are two things. Well, there may be 3 or 4 things also. Now the thing is, if I try to explain you the game, it will take some time. Let's not explain the game. And let me tell you, I am very good in this game. So you cannot beat me. You will lose. I guarantee you that. But still, I want you to play. as you know that you will lose, and it doesn't matter how you play, I will let you choose. Do you want to go in the first turn or in the second turn? So there
Sir,
is
didn't get your
game. First I will play, then you will play. It will be alternative play. So you want to go first or second? I will explain you the rules after that.
the second.
Sorry?
I will be second.
Second. Okay, fine. So where are the pins? Right. Okay. Now, as there are many volunteers and the game is something very one-sided, it's almost I have a cheat code. So maybe I can, after a few turns, I can change volunteers. Okay. So now, first turn is my turn. You see, the rule is very simple. The rule is that you have 4 tips of each of the sprouts, A, B, and C. You have to join any 2 tips. You can join the same tips also of the same sprout. Okay. But you just have to join 2 tips, something like this. Okay. So let me go. Let me do it. So mine will be, I will try to make my things blue. So this is my first move. And then after you join these 2 tips, you cross it with a line. Okay. And these 2 becomes new tips. So you see, basically 2 tips are gone and 2 tips are closed, I can say, and 2 new tips are there now. Now, Kalpana will join 2 things. There is only one rule. You can never cross 2 lines. So if Kalpana draws another line, if she uses the color red, she cannot do this. This is not allowed. However, she can do something like this. Okay. So once you cross the line, you lose. So don't lose intentionally. That will be bad. So now, Kalpana, your turn. You tell me from which one to which one you want to go. A, B, C, or the new one?
So you have connected A. So from that to next.
So A to B, I have connected the top tip of A to the top tip
Yes, sir,
of
top
B.
to from eastwards.
Yeah, these
So
are closed.
A
These you cannot use anymore. So which one
Okay,
do you want
sir.
to use?
Sir, east and
Choose anything. Don't choose
south
too
one.
much.
Sir, A ka east or south?
A is east and south. So you are going to do this, right? Okay, great.
Yes, sir.
Now what I'm going to do, I'm going to do this. Okay. Now what are you going to do?
सर वो आप जो ब्लू पे जो बनाया ना उनको ज्वाइन कर दीजिए.
Blue पे जो डाले हैं उसके साथ which one?
सर दूसरा जो blue वाला.
Okay, so you are saying this one. This one.
Yes, sir.
Okay. Now someone else maybe after my turn. Thank you, Kalpana. After that, Moshumi, please get ready. You think of your move. And I'm telling you, don't think too much. Whatever you move, I'm going to win. So Moshumi, what is your, which ones do you want to join?
Sir, from A to B, middle is
Okay.
end থেকে
B এর কোনটা? নিচেরটা না সাইডেরটা? এর তো একটাই খোলা আছে। নিচেরটা না সাইডেরটা B এর? সাইডেরটা, ঠিক আছে, আমি যে কোনো একটা করছি। আমি ঠিক শুনতে পাচ্ছি না, I'm not able to hear you properly, but you said A and B. So let's see A and B. Okay, good. Now it's my move again. So let me do this one and cross it here. Okay. And who else? Now Moshumi, another one, maybe.
সি এর সাইডেরটা থেকে সি এর ওপরে যেটা আছে ওটা।
Okay. Thank you, Moshumi. Now maybe Choiti may get ready for the next move after my move. Okay, what is my move? My move, I will probably do this one. Okay, now Choiti, can you tell me which one? It's going to end very soon, so please do not think too much. Just say any move is fine. Even I am not thinking. Choiti, are you there? You can type in the chat box. Okay, thank you, Choiti. Please tell me which ones do you want to join?
সি এর বাম দিকেরটার সঙ্গে ওই এ আর সি এর যেটা হয়েছে ওটা মাঝখানেটা।
Right, I got it. This one, right? Okay, now my move. Okay, now your move. চৈতি, আচ্ছা না, জ্যোতিকে একটা চান্স দিই, ঠিক আছে চৈতি? জ্যোতি, your move, please.
Yes, sir.
Because I think not many moves left, so maybe Jyoti can use a move. How about you, Jyoti? Please go ahead. Konta konta. Oh, I am not C2A. Okay, okay. Sorry, no C2A. There is nothing. There is nothing because there is nothing. So, anyways, you said C. C, from C there is only one move. This one. Okay. And now my move. And as I promised you before, I win. There is no more moves left. You can see. So the only open tips, let's verify once. So I win. You cannot move anything anymore without crossing. I win this. So you see from here, where will you go? In this whole empty thing, there is only one open tip. So you cannot connect it with anything without going outside this enclosed region. Okay, there is only open tip, only one open tip. There is another open tip here, but that's in the other side. Sorry, what am I doing? Sorry. Let it go. Let it go, and after that I will enclose again. Or maybe I start with an easy one. So you see, let it go. Otherwise, it will be confusing. Okay. You see, inside this region, there is only one open tip, this one, nothing else. Similarly, inside this region, there is only one open tip. Outside, there are many. This one is there, this one is there. I don't care about the outside ones. Inside this region, there is only one open tip, nothing else. Okay. Did anyone count that how many moves we played? What was the number of moves before the game ended? You can write in the chat box if you count or something. You can count now also if you want to. But okay. Can you tell me if it was odd or even number of moves? That should
Even.
be easy. I started the game and I won.
Okay, that is odd.
That is odd because I won. Okay,
Because
great. So who is this speaking?
different.
No, Aritro. It is
Hello.
it is actually odd. Yes, Kalpana, you are correct. But Aritro, it is actually odd because I started, no. So it was actually 13 moves. I'll tell you, it was 13 moves. And why I was saying I have a cheat code, because no matter how you play this game ends in 13 moves. That we will show how. And there was a chance that Kalpana will ask me that Kalpana will go first, I will go second. In that case, I wouldn't have added this third one, you see, because with 3 initials, it ends in 13 moves. With 2 initials, it ends in 8 moves, even number. Then I will be the second player and I will still win. Okay, so that is extreme cheating from my side, but now I will explain the cheating. Okay. Before I explain, very quickly maybe, let's see if this actually ends in 8 moves or not. I will not change colors, okay? So let's see. I'll just do anything. So 1 move. Let's change colors in this. 2 moves. Okay. 3 moves. 4 moves. 5 moves. 6 moves. 7 moves. 8 moves. See, I told you it will end in 8 moves. It did. So if I were the second player, then also I would have won. But why? So now, to explain why, we will explain you something called a planar graph. So this is where we begin with graph theory, okay? So you see, what is a planar graph? A planar graph is a graph. All of you know graph, right? Are you familiar with the term graph? Or otherwise I can explain, no problem. You can just tell me in chat box. Yes, no. So yes means you know about graphs. What is a graph? And no means you do not. Please tell me in the chat box. Yes, yes. And don't be shy if you do not know. Anyways, okay. Okay. Most of you know. Okay. Great. So anyways, graph is this, there will be some vertices. There will be some lines connecting the vertices. These things are graphs. For example, this graph is called K4, complete graph on 4 vertices. Anyways, so now my question is that is this graph planar? The graph I drew here, is it planar? I'll name the vertices A, B, C, D. Any answers in the chat box? So please tell me, planar or non-planar? Not planar. Great. And again,
Probably they are knowing about the graphs.
Sorry, Shomenda?
Well, probably they are knowing about the graphs and planar graphs. I am seeing in the chat box actually. You can
No, but they said no.
No.
They said this graph is not planar.
Oh, acha.
Yeah. Yeah, they know about graph, but they do not know what is a planar graph properly. That's fine, no problem. I mean, this is a very common mistake. That's why I gave this example. Now you will remember it forever. You see, forget about this sphere. That part you forget now. Okay, so I will actually erase that part. Actually remove that part. So what does it say? A graph that can be drawn on the plane without its edges crossing. This can be is very significant, because you see the particular graph, the graph I have drawn, you have correctly said this has a crossing, but it doesn't matter, because what I can do is I can actually remove this edge and draw it in a different way. You see, so this graph, the graph I drew before, it can be drawn without its edges crossing. It's a different story that the previous drawing, the one I drew it, the way I drew it, I did not draw it like a planar graph. I draw it with crossing, but it can be drawn. So it is actually planar, okay? This is planar. This is a planar graph. Now, there are several graphs that are planar graphs, but that is a different theory. Let's not go there right now. I want to prove one of the very earliest theorems for planar graphs right now. But it's an easy proof. It's a proof with induction. But let me get some things straight. So this A, B, C, D, these points, these are called vertices. These lines joining the points, these are called edges. So let me write it down. Vertices. And now you see these ABD or ADB, this has created a triangle. Inside there is an empty region, which I can color without taking up my pen or crossing the edges. So this region is called a face. So how many faces does this graph has? What Jyoti Malik says is it can be drawn as a planar graph, but initially it was not planar. So exactly that, Jyoti, what I want to say is the definition of a planar graph does not depend on the drawing. It's just a graph. Now, if you can draw it, if there is a way to draw it in a non-crossing way, then it is a planar graph. The drawing doesn't matter. The possibility matters. Okay, so that is how this definition is kind of a little tricky, but it is how it is. So no matter how you draw the graph, if it can be drawn as a planar graph, if it can be drawn without crossing, then it is a planar graph. Okay, so how about this? So this is a face, this is a face, this part is out. So how many faces do you have of this graph? Of this particular graph, how many faces are there? 3. Okay, good. You are almost correct. Let me see. 1, 2, 3. Now there is something, this outside, this is the unbounded face. So this outside is also a face. Okay, so you can think of it as bounded by this, so separated by this cycle, but the outside part, outer face, it is called the outer face. It is something special if you draw it on a plane, but nothing special if you draw on a sphere. But I'm going to skip this sphere part for this talk. It is there, but let us skip. So the answer is actually 4. Okay, you see these are faces, right? These are faces. I don't know how many faces here, but notice something. This we will use later on. Inside, say, this face, let's take a small one, inside this face, the game ended because there is only one tip. Now I couldn't have created this face if I didn't draw whatever the last line I drew to make this face was stabbed by this black line. So there will be one open tip here because this tip is unused. I did not draw anything inside after that. But if by chance there was another tip here, then I could have joined these two. So I could have drawn something else. So that means there is no other tip. Once the game ended, inside one face, there can be only one tip, one open tip, and exactly one open tip. Okay, so you can see in every face, there is exactly one open tip. For example, this one. Even in the outer face, this is the contour of the outer face. There is one open tip, this one. This is the outer face. No? So this observation we will use later on. But let's go ahead. Now, the form, so face. Let me use a bit better handwriting. Let me try. So vertex, edge, and face. Okay, these are the three things. Now for vertices, we will denote it by V of G. This is the set of vertices. So actually what I have written here is a bit wrong, in the sense that this will be cardinality. All of them will be cardinality. So what I'm saying is, you take any connected planar graph, doesn't matter which one, you take any connected planar graph, you count the number of vertices, you count the number of edges, its number of faces, including the outer face. No matter how you have built the planar graph, number of vertices minus number of edges plus number of faces will always be this constant 2. It's amazing. So let's see, for example, this one. Let me see if I can copy this into the next one. Okay, good. So how many vertices are there? Please use the chat box. I need your help. How many vertices are there in this graph? 4. How many edges? Faces we already know, it's 4. How many edges? Koena, Sanjana, no, Sanjana, it's 6. Please count. It is 6. You may have missed one somehow. Okay. So what is it? 8 minus 6. It is 2. See. But you see, it's one example. It's not a proof. It's not definitely not a proof. So how do we prove it? Okay, we prove by induction. Okay. We prove it by induction. First, let me, do it for the simplest kind of graph. There is one vertex and no edges. So how many vertices are there? It is 1. How many edges are there? 0. But how many faces are there? This is a question. Can you please use the chat box to answer? Exactly. It is 1. It is the outer face. So that counts. So it's another trick question where people answers with 0 many times. So it's not true. It is 1. I'm sorry. Yeah. So it is 2 in this case. Okay. So this formula is also true for multigraphs. So let us prove it for multigraphs. So if you have a loop, multigraph or loop, graphs with loop, then you see you have one vertex. Let me draw it here. Minus one edge and 2 faces. Still remains 2. Still it is okay. If you have one vertex and multiple edges, say m edges, okay, then how will it look like? It will look something like this. Many edges are there. But you see, as soon as you draw another edge, you draw it inside a face. If you draw it like this, you are actually drawing it inside this face, and you are dividing this face into 2 parts. One is this part and one is that part. So you are increasing number of faces by 1. So if I have m edges, let me draw it this way only, then it's easy to say. Sorry, it's yeah. So let me say this is E1, E2 and EM. Okay. So how many vertices are there? That is easy, 1. How many edges are there? That is also easy, M. How many faces are there? It is m plus 1. Play around it and you'll see it. Okay, even if there is some confusion. So there is an outer face, and for every loop it creates a face, inside face. So this is 1, this is 2, and so on. This will be m, and this will be m plus 1, this outside face. So for any such graph, any graph on one vertex, our claim is true. Okay, so this is our base case, induction. So induction true for Vg equals to 1. Now how about if I increase it? Okay, now you can know. I want to tell you something called edge contraction. Okay. So suppose there is an edge. If I contract this edge, so this is an abstract drawing of a graph. If I contract this edge, that means somehow I'm forcefully merging these two and shrinking the edge into a single vertex. So how I am doing that? Let me draw some example graph explicitly that will help you understand. Something like this, let's say. Okay. Now, if I contract these two vertices, what I will do is I will remove this edge, or maybe I keep this edge. I will put a vertex here. Sorry. I will put a vertex in the middle, and I will connect this vertex to whatever u was adjacent to. So that means this one is there. Well, let me actually remove these two vertices, and what? No, became too much. Right. Okay, so what I'm going to do is, just give me a minute. Okay, good. So what I'm going to do is, let me name A, B, C, D. I need a few more vertices. Okay. Now, whatever vertex was adjacent to U and V, I will make them adjacent to this new blue vertex. Okay. This was adjacent to U and V both. So it will look like this. So basically what I'm doing is I'm shrinking this blue box and making it one big vertex. You know, this becomes a vertex. This edge I'm shrinking it and it becomes a vertex. So this is my new graph. So if I draw this blue very small, then the red will look like, the other vertices will look like sorry, there is some problem. My laptop is actually getting heated up. So I have to do something. Yeah. Just give me a second. Okay, now it's fine. So it will look something like this. Something like this, okay? Yeah. Is that clear? Please use the chat box if it is not clear to tell me. So basically this big thing, this big blue thing, I'm making it a vertex. So this is edge contraction. If it is not clear, maybe I should give a better example. Please tell me if it is clear in the chat box, because this is the one most important point in this talk. Everything depends on this. So maybe I should try to give you a better example somehow. Yeah, this is a better example. Hello, are you guys there?
Yes, sir.
Okay, so please tell me if this is clear for you, because this is important. So this UV became this thing, and now if I draw all the vertices, A, this is a new example, okay? The previous example was a bit messy, so I am giving you another example. So here, you see with this new blue vertex, there will be two edges with B, one edge with A, because only U was adjacent to it, not V. One edge with C, D, but with E, there will be two more edges, okay? And maybe you had these edges beforehand, okay? Then you will have these edges also. Those will be intact. Now tell me, contracting something, does it decrease the number of faces? Yes or no? So if I
No.
contract edge, does the number of faces decrease? No, right? Okay. So here is your induction step. So induction is on number of vertices. So suppose it is true for all vertices, all graphs which has VG less than equal to n. Okay, true for all graphs which has VG less than equal to n. Now you take a graph which has number of vertices n plus 1. Now your graph is connected, so there must be edges in the graph. So take one edge, contract this guy. Okay. So if you contract it, that means one edge is getting vanished. So suppose your graph, this VG, whatever this G is, it had a number of vertices n plus 1, number of edges was m, and number of, or e, small e maybe, number of edges was small e, and number of faces was small f. Now you contract this to make a smaller graph. Okay, make a smaller graph where you have contracted already. So this is the contracted after contraction. Okay. So in this graph, what will be the number of edges? Any answer in the chat box, or you can just say, what will be the number of edges here in this one? Here the number of edges was E. What is the number of edges in this one? You see, you have contracted one edge. The other edges are as it is. It doesn't matter if you say something wrong. Please go ahead and say it in the chat box, please. E minus 1. Good. Saloni says it is E minus 1. So this one has E minus 1 edges. How about number of vertices? It had n plus 1 vertices. See, two vertices, they merged and became one vertex. So it's again n plus 1 minus 1, that is n vertices. And number of faces, as we have seen, it remains the same. But as we are doing induction, you see our formula is true for everything which is less than equal to 1. So in particular, it is true for this graph. Okay, wrong pencil. In particular, it is true for this graph. So what it means is, if I plug in these values in this formula, in the right hand side, I will get 2. So what will we get is that we will get n minus e minus 1 plus f equals to 2. But what if I plug in these things in the formula? What do I get? I get n plus 1 here and e here. It's the same thing, basically plus minus 1. So I'm adding 1 here and subtracting 1 here. It was e minus 1. So if I plug in those things, let me write it here, then it will become n plus 1 minus e plus f. That is also equal to exactly this thing. That is 2. So if it is true for n, then it is also true for n plus 1. This is how the induction works. So that is why this formula is true. Okay, number of vertices, no matter what your planar graph is, the number of vertices minus number of edges plus number of faces is 2. Okay, so we have this result. So you may be a little confused about the proof, but have you got the general idea? Please tell me in the chat box. Then I can move on to the next thing and I will quickly wrap up. Okay, thank you, Payal, Aritra, and okay, great. Now, how about Euler's formula and Brussels sprouts? Let's see. Let me bring one of the sprouts, you know, this picture. Let me bring this picture there. That will be helpful. So this is the cheat code for this game we are going to discuss now. So what did we start with here? You see, I will make that part prominent. We started with 2. This is the second example. The third one I'm avoiding because of time constraints, but we started with 2. So that means how many open tips were there to begin with? 8 open tips were there. Okay. Suppose the game ends in n moves. Suppose the game ends after n moves. Okay, suppose that we want to calculate this n. Okay, at the end of the game, what we got is a planar graph. There is no crossing. These guys are vertices. These crossings are vertices. These yellow and red things are edges. Okay, well, this is an edge. This is the another edge. Okay. Now let us try to calculate the number of vertices here. VG. What is VG? In the beginning, you see, when we started the game, we had 2 vertices. And then suppose this was the first move. And then we crossed it. So we created another vertex in the first move. In the second move, we created a vertex. So in each move, I created a vertex. So that means I started with 2 vertices, and in n moves, I created n more vertices. How about EG? I started with, this was the initial situation. Okay. I started with 0 edges. There were no edges. Now what I did something like this. So I created 1 edge. I didn't stop there. What I did after that is I crossed it. So I made 2 edges, one here, another here. So in each move, I'm creating 2 edges. So that means what I can write here is 2n. Number of edges is 2n. And number of faces, well, here the hard work we have already managed to finish. It's the number of open tips, because each face, remember we have observed before, each face has exactly 1 open tip inside them. You can prove this with a bit of hard work. I'm not rigorously proving this, but you can prove it. Observe here, each face has even the outer face has 1 open tip. So number of open tips, but how do I count the number of open tips? Again, let us go back to the initial position. How many open tips were there in the initial situation? Please use the chat box to tell. So this was the initial situation. How many open tips were there in this initial setup? 8. Good. And then what did I do? I closed 2 of the open tips, and then immediately after that I created 2 more. So I closed 2 and I opened 2. So it remained 8 even after the first turn or second turn. So whatever the initial number of open tips were, it remained the same. This is 8. Okay. So now you have it. So this is your calculation. Now use the Euler's formula. Okay. Let's plug in. Let's plug in these numbers. So V, let me write it here, then it will be corresponding. N plus 2 minus 2n plus 8 equals to 2. You can solve n. It is a linear equation of n. What you will get is n equals to 8. Okay. So I know no matter what, this game will finish in 8 moves. Okay, good. Now let me do a bit more and then I will stop. I will not be able to do the football thing. Okay. So the next one is, suppose in the initial, how many pieces were here in this calculation? Initially, there were 2 pieces. Suppose not 2, not 3, but there are something like k pieces. Okay. This sprout 1, sprout 2, sprout 3, sprout 4, and sprout k. Suppose there are k sprouts total. And in each turn, how many am I adding? I'm adding 1 vertex. So initially there are k vertices. Okay. Initially there are k vertices instead of 2. And in each turn, I'm adding 1 vertex. So this is k plus n. For edges, initially there are 0. And in each turn, I'm adding 2 edges. This remains the same, 2n. And for faces, again, I have to count the open tips. But how many open tips are there right now? Please tell how many open tips are there in the initial situation where I have k edges, k sprouts, 4k. Great. So that will remain the same, 4k. Now let us plug in here. Okay, n plus k, 2n, and this will be 4k. So if I solve it, n will become 5k minus 2. If you plug in k equals to 2, that gives me 8. If you plug in k equals to 3, that gives me 13, 15 minus 2. So exactly what happened. This game ended in 8 moves. The previous game, the first one we played with 3 sprouts initially ended up in 13. The next one, as you can see, it is 5k plus 2. So the parity, the number of moves depend on this k. So if you put even number of sprouts, then the second player wins. If you give odd number of sprouts, then the first player wins. Okay. Is that clear? Please use the chat box to say. So this is the result. That in this Brussels sprouts game, using Euler's formula, we can show that if we initiate with k many 4 sprouts, by 4 sprouts, what I mean, yeah, this needs a little bit of clarification. Well, not too much. This is a 4 sprouts because this has 4 open tips. If it had, say, 3 open tips, then it would be a 3 sprout. But probably the game will not be so interesting. So I will make it, keep it more than 4. So it could be a 5 sprout also, like this, or 6 sprout. But we restricted ourselves to 4 sprouts. So if there were k 4 sprouts, then 5k minus 2 will be the number of steps. Now I have some questions. The question is, suppose you have k sprouts to begin with, and the sprouts names are b1, b2, bk. Bi has ni open tips. So maybe the first one has 4 open tips. The second one has 5 open tips. The next one again have 4, then 6, 8, 100, something like that. Then can you say how many steps, in how many steps the game will end? This is an interesting question. You can think about it. And the second question is, well, this is a bit more difficult, but this may go on for, this may approach some research problem. I'm not sure. You have to search about it. But other surfaces, instead of playing it on the, this sphere or plane, if you play it on a torus, let's say, something like this, okay? Like a idli vara or a tire, something like this, what will be the results? Because you have some Euler formula for these guys also. Or a double torus, something like this. it's the same as a cup with a handle. It's the same as a cup with a handle, topologically same. But I think most of you are CS students. But anyways, you can write to me if you want. So that's all. Are you clear? Are you guys clear about this? The next topic I will skip. I will not go to the next topic. This is a good time to end. Yeah, actually that is time, and I think I have already interacted with you. So I think I can stop now. And I hope that you like the talk. Oh, and just in case if you want to email me, I forgot. I was listening to Shomenda's talk, and then I realized that I forgot to give my email ID in the slides. Anyways, you can write to Shomenda also if you want to reach me. We are extremely close collaborators. We speak every day. So sometimes it may be even quicker. If you want to reach me, you email Shomenda. That may be quicker because he may see my email before me, see his email before me, and tell me over phone. Anyways, thank you. Thanks a lot.
Thank you very much, sir. Dr. Sagnik sir, thank you for your interactive and interesting session and making this session more fun. Students, if you have any questions still, you can ask now and you can contact to sir later also.
Yeah, anytime. You can contact me anytime. No problem. Please send me an email. I'll be happy to speak to any of you.
Okay, I think
if you have any questions or comments or anything, yeah. Okay, and I would also like to thank Professor Dipannita. She approached us, and she's a student of Shomenda. She came to ISIE a few times. I think we met at that time also. And thank you, Aru. So everyone, thank you. Thanks a lot.
Am I audible?
Welcome, sir.
Yeah, you are audible. Yes.
Okay. First of all, I may like to express my sincere thanks to both of the speakers for giving an excellent coverage to randomized algorithm and graph theory, and of course for the games too. Actually, and of course, Shomen sir, it's really great to hear you after a long time, and I am very much obliged. So, thanks once again. Let's proceed to the next session. And over to Adu.
Thank you, Dipannita madam, for organizing this nice session and approaching our eminent speakers. So thank you all the speakers for giving their valuable time. Thank you once again. So we will proceed for the next session. Before proceeding the next session, I think we have some break time. So we'll come back after 5 p.m.
Okay, thank you. Bye.
Thank you, sir. Okay, now we are back again. So now I welcome Dr. Jyotsna Kumar Mondal sir for his valuable speech. And before that, I introduce sir. Sir is the professor of Department of Computer Science and Engineering of University of Kalyani. And sir has served renowned position in various organizations, and sir is the former Dean of Faculty of Engineering and Technology and Management, Director of IQAC, Chairman of CIRM and Placement Cell, Kalyani University, and also he is the author of numerous papers and books. So now over to sir, JKM sir.
Thank you, Arup, for your introduction. So, good afternoon, all. I think the participants must be tired in getting the inputs from various scholars of this field, experts. So, I am today going to share my ideas and knowledge about just a new trend, that is your software defined network, which is the future trend of our network scenario. So my topic is software defined network. So this is the introduction already Arup has given. If we think of a classical network, you see this is one structure of a classical network where we have number of switches. Suppose if I think of that these are all fiber optic switches, definitely this must be inside some buildings. And these are the ports connected to various computers or devices. So we normally consider this as a plane which is called the foreplane, and this backbone or background network communication is the backplane. And nowadays all of the switches are in general managed switch. And what managed switch have? They have some dedicated memory, we have some control software, some ways from the maybe Linux or maybe other. So when I am sending a data from this node to this node, that is a four-plane communication, and this is a star. And this network is a composite star bus network, star bus composite network. So the data will be multiplexed to other node. But when it will going to some other switch or other building, so backplane is taken into the action, and it goes to the queue into the memory, and is the fast come fast. So packets are forwarded based on getting the other acknowledgement from the other node. So this is the network scenario. That means the complete network and the forwarding decisions or routing tables and all others are ported into this switch. But this switch does not have any idea about this switch. Only thing that I have a link, and if I need a backplane communication, I shall send the data to this backplane communication. So these are some more closer look that how we connect. These are connectivity platform. I'm not going to do that. Now, if we consider an internet scenario, suppose one web server is there in a network in an institution. So what we are doing, that we have an exchange. So if it is a Midnapur college, then it is a Mohila college, then it's from the exchange, BSNL exchange. So maybe nowadays is wireless or maybe fiber optic. So earlier it was the copper cable. So that was the modems was at 2, right? Nowadays these are OptiMask, and these connectivity are optical fiber. So from there it is coming to a router first, and then your local network. So when it is forwarded to a particular server, it may be PDC or BDC, there may be mirrors and other things. But suppose I am going to a mail, so this does not involve anything. That means these are all isolated ACR. So I cannot take part for others. That means this is the active network scenario. Your switch perform the custom computation on packet at the local node. Tracing, firewall, proxies, these are. So what is the problem? The networks is a difficulty on integrating new technology. When I am purchasing one network node, a switch from Cisco, that means they are giving a software, they are giving some systems, it is proprietary to them. I cannot move to some other. Heterogeneous integration is not possible. So that means the system is a de facto standard. So this is some of the, when the deployment fails, suppose one switch at your department is failed. Now, no other switch in your other departments act as a forwarding system to your departmental packets or the message. It is those things that you have to replace it or you have to repair it. That means the isolated sorts of things. There is no centralized control or centralized management system. That is the scenario. And in any traditional WAN routing, we are treating all bits the same. And average utilization is 30 to 40%. And we have various cost of bandwidths and other. Now, the scenario is coming nowadays where I can have some options to overcome this problem. What is that? By using software defined network. Suppose complete network of my institute need to be ported from one place to another place. That means I have to physically defabricate all these components. So how do I do that? So now what is an SDN? It is restructuring the current network infrastructure for improved network management. It is not a new one. And here you see your data and control. Both are in a single place and in a single switch in traditional network switch. But in software defined network, your control and data planes are decoupled from traditional forwarding devices. What is in your lab or in your institute? What is the definition of a software defined network? The software defined network is an emerging architecture that is dynamic, manageable, cost effective, adaptive, and making it ideal for high bandwidth and dynamic in nature. And it decouples the control and forwarding functions, enable the network control become directly programmable, which I cannot do. Only I can port the programs, port the routing tables into a switch. I cannot do more than that, and that is a static one. So in SDN I can do that. Now what is the control plane and data plane now? The control plane is that the module which takes all decision, basically as an instructor, routing algorithms, all decisive work is separated from the data plane and ported into a plane which is called the control plane. Now what is data plane? The module which carries out the task given by the control plane. That means it is a dynamic in nature. So when it will give, when some work is there, packet is coming, so then the decision rule will be given the forwarding rule, where to be forwarded, how it to be forwarded, what is the routing technologies. What is the work of the data plane? It is a forwarding of packets after getting the rules from the control plane. You see, this is the conventional networks. What is going on nowadays? We have user 1 and user 2. So you see someone sending the data, and this is my switch and this is the flow. Now if I think of a situation that this switch is out of order, then I cannot change the routing table if it is a static routing. So now my network is stuck in my campus, or whatever the connectivity is here, that cannot be ported to here or here, or this switch cannot take decision on behalf of this switch. So the switch has been attacked, need to route through an alternative path. Can you do that now? No, because there is no centralized control. This device does not know anything about the neighboring device. This device does not know anything about this neighboring device. Only the thing is that I have a connectivity, I have some control software, I have some routing tables, IP addresses, so it will forward the packet. If it is not possible, it's a failure. If we give a ping command, so ping unreachable. So this is the current scenario and problem of the existing network. That means, you see, apps, OS, hardware, everything ported in each of the network devices like this. So the switches have forwarded the traffic in a distributed manner, and they do not have a global view of the network. Never. This switch does not know the view of this switch or the global scenario. No scenario. It is only a localized scenario. It's not the local conceptual frameworks. It is ported into that device. So global view is absent. So traditional networks are mainly proprietary. When I am buying a network, buying a switch, it is either from Cisco or from Lenovo or from HP. So vendor specific architecture of switches limits the dynamic configuration according to application specific requirement. And switches are required to configure using the installed operating system. So if Linux operating system is portable, so I cannot use some other operating system into the switch nowadays in this conventional network. And also centralized control is not possible in a traditional network. And what are that? When I am writing the codes, 1,000 lines of codes are there in each switch. Routing tables are there in each switch. So we have all these things which is make this deficient. So now let us move from the current network to the present scenario. What does separating the control and data plane mean? How it's separated and why it is separated? Vendor only provides the hardware. That is your box and the hardware device. We decide the control plane by writing the custom logic, the software. What is the advantage? The features are no longer limited what vendor provides. So you have to write, you have to port your logic. So you can go for a community development for your campus. So longer life of the product, because if the development product is changed, so everything will be changed. It is only black box. The rest of the things you are integrating this. So compared to the traditional networks, a software defined network has two types of devices, so controller and switches. The switches of the SDN is blind. That is no built-in feature and need to be instructed by the controller only. You see, this is the structure. You see, this is the controller and this is the data plane. So your SDN controller is the brain of the network, and all policies, routing, logics are placed in the controller. It teaches the switch what to do with an unknown packet. So let us see a scenario that a packet want to move from H1 to H3 in SDN environment, from this H1 to H3. So how it will happen? You see, at the beginning it is blind. So source is H1 and destination is H3. So it need to forward a packet from here to here. So at the beginning nothing is there. You see, table is missed. No rule is there whether the packet from H1 to be forwarded to H2 or not. Then the controller forward the rule. The packet is buffered, then rule is received by the node. Then the rule is installed at the TCAM hardware of the switch given by the controller. Then it will forward the packet based on the rule. That means it's a dynamic in nature. So now what is the architecture? General architecture of SDN has three layers. One is data layer, one is control layer, another one is application layer. In application layer you have the traffic engineering, routing, security, everything, and you have a northbound API and you have the southbound API. And in the data layer you have the forwarding devices, all the devices in the data layer, and in the control layer you have the operating system. So this is the architecture, that we have the controller where we have the northbound controller and southbound. So northbound controller is using for the traffic engineering, routing and security. Southbound controllers manage the devices in the data layer. And this is the network operating system. So we have typical representation is that SDN architecture consisting of three layers: the application layer, control layer, and the infrastructure layer. Yeah, this is the SDN architecture. We have the controller, southbound API, northbound API. These are the devices, router, switch, all other any devices. These are connected here. How SDN works? SDN encompasses several types of technologies, including your functional separation, network virtualization, automation using programmable feature. So network control plane makes the decision how packet flows. And what is the benefit? Prioritizing, deprioritizing of a specific network traffic, high granularity of control, end-to-end network management, end-to-end network visibility, and centralized controller based policy dissemination, management of suspicious traffic. So how do we implement the SDN? What is the base of the SDN? The OpenFlow WAF is considered one of the first software defined network standard. It was originally defined to act as a communication protocol in SDN environment. So OpenFlow enables the SDN controller to directly interact with the forwarding plane of the network devices like this. You see, we have the applications, we have the network base, we have the forwarding hardware, and that we have the devices under this. What is OpenFlow? It's a protocol for controlling the forwarding behavior of Ethernet switches under SDN. It was released by Clean Slate program at Stanford, specification now maintained by Open Networking Forum. It's a layer 2 communication protocol. Your OpenFlow is a layer 2 communication protocol. It gives access to the forwarding plane of a network, switch or router over the network. How OpenFlow works? It enables the network controller to determine the path. And your controller is a separate entity and distinct from the data plane. And you have the access control list is there. It allows single open protocol to manage the network traffic. And it also allows the remote administration of a layer 3 switch packet forwarding tables. But it is not ported into the data plane. And it's achieved by adding, modifying and removing the packets. And routing decisions are taken by the controller. It's a protocol is layered on the top of TCP. It says protocol layered on the top of your TCP, transmission control protocol, and it uses the transport layer security or TLS. Always your controllers listen to the TCP port 6653 for switches that want to set up the connectivity. So I cannot say that the OpenFlow is an SDN. OpenFlow is a subset of the SDN. How OpenFlow works? You see, this is your switch. You have the data path, your device, your control path, and your OpenFlow message API and OpenFlow controller. Now let us go into deep. So is the OpenFlow client. You see, source MAC, destination MAC, source IP, destination IP, TCP, a source TCP port, destination TCP. So these are the Ethernet and these are the devices connected like this. So OpenFlow protocol. Now let us consider a scenario. See, we have the Bob forwarding application. Bob wants his own set of network rules to forward this packet. I can generate a own network rules. Suppose here. This is the flow. Bob's forwarding application. Now, Alice has the forwarding application. I'm using the same network architecture. Now his application is like this. That means on the same network, I can define two set of rules which are different and distinct. So that means the applications are different, rules are different, and at any moment, suppose one node is out of order, I can take the decision that the routing can be changed based on the availability of the routes. So we have already discussed that we have the centralized control plane, but in normal network is a distributed control plane. That means everything is ported into your switch. These are some of the rules. You have the rules from the OpenFlow table, from the SDN controller. Then you have various rules for that, IPSSC, IP destination. So all these things are there. Then actions, what are the actions? Forward the packets, encapsulate, modify, drop, whatever the actions based on the rules and the security and the protocols. So you generate the statistics, you define the priority on the runtime, which cannot be done using your traditional network system or network switches. This is some of the example. You can see here, you see some actions, source routing, VLAN routing. So now another thing is there, I am separating the data plane with my control plane. by giving a centralized control over the network with some uniform protocol systems which can be changed on the fly. I am giving a rule now. After 10 minutes, I can change the rule, which is not possible in the traditional network. So this centralized system may suffer some problems in terms of attack. There may be flooding and DOS attack, host hijacking attack, tampering attack, spoofing attack. So let us consider the flooding attack and DOS attack. Your attacker may devise a DOS attack to make the controller down. Because I have a single controller, I am controlling all the devices. So if controller goes up, everything goes up. So control plane requires request from the forwarding plane for flow rules. This leads no response, may be stuck. So open flow switches may have some problems. Another problem may be host hijacking attacks. These are the potential areas where we can go for our research, and because these are all open nowadays. It's a spoofing attack by exploiting host tracking services. Your HTS is a network-wide view and essential service in SDN controller. So this, if the controller is hijacked, now HTS may also be deployed as per their rule. That is another problem. Now tampering attack. So in SDN, northbound API and southbound API messages are used to manage the network. So in tampering attack, this northbound and southbound API messages might be spoofed and insert some malicious flow rules. So everything will be malicious. That means the security of SDN, because I am giving it more open, I am giving it more centralized control, because rules are dynamic. So some spoofing rules, if injected, now it is not possible for the data plane to detect that rules, that this rules is a fake rule or malicious rule. So these are the attacks. Now spoofing attack also. In the event of successfully spoofing attack, the attacker can create and update the entry of the flow table. So these are the vulnerabilities of the SDN system. So these are some of the vulnerabilities we have already discussed. Now, how do we manage the controller in this open scenario where the attackers are there, spoofers are there, man in the middle attackers are there, because the controller is the main component of the software defined network. So there may be a major possibilities of failure of the controller. So the controller has to be prevented from malicious attack. So if we think of a backup and restore system, what will be the benefit? In the event of failure of the controller in a single controller environment, there may be a massive chances of network breakdown. So other solutions related to the multiple controller environment, there may be an environment where I can use multiple controllers. So one controller if goes off, then I can assign the task of that controller to the neighboring controller. So therefore, there is a requirement of this type of solutions that I can go for some separate mechanism. What are the mechanisms? Some mechanisms are available that can be a BRS, backup and restore system. That means if some inconsistency in software defined network controllers are there at certain moment of time, the backup and restore system will take the policy decision. Copy of the rules will also be there. When the integrity is reached properly, then its release for is working. So this is a schematic architecture of the SDN with BRS. It's taken from one NASA journals, some of the research group from our lab done this work. You see that we have some SDN controller, devices are there under SDN, devices are there under SDN. So a BRS is added into the complete network architecture. So if any problem on the integrity of this network, so job is assigned to the BRS. Then BRS will make a restoration systems and then it will give it back after repairing the problem. That means in the event of failure of a particular controller, the BRS will assign the job of the controller, which is not working to a topologically adjacent controller. It may be some other places. So in this event, the current state of controller is required. So this information is fetched from the BRS to the assigned controller, and the working will be done. Then when it restored, the control is handed over to the main controller. So you see, this is, we have various controller and we have the BRS. And these are the devices. Now another architecture is also available where we have the controller as a master controller and slave controller. That means if there is a problem in the master, slave will take the responsibility. If there is a problem in the slave, master will take the responsibility. And overall, all of these master slave configurations, BRS is there, who is working as a supervisory control, and for each and every network controller, they are checking the integrity, rules and all others. If any problem is there, so this integration will be done by the BRS, and then the restoration will also be done by the BRS, and after restoration it will give back the control to the master or slave based on the situation. So the steps are that: controller failure detection, authentication and recovery. These three steps are normally done by the backup and restore system. How it go for backup and restore system? Suppose BRS have some computing methodology. The code is computed here, one methodology is given, that using some arithmetic code which gives the probability of using the various controller, their codes, keep it and check the integrity by an agent for the controller with BRS. If integrity rules violates in terms of computation of the decoding of the arithmetic coding, then it seems that the controller has been compromised, and to take the charge of the controller and take the rules, rules are deployed for forwarding the packets and all others. So this is some authentication process. I'm just skipping this. Now controller recovery process. In this architecture, after recovery of the existing controller for a particular subnet, BRS will hand over the control plane to it, and some process of authentication will go on fly based on some agent based system. Once handing over process is complete, the assigned controller is relieved from the additional management of a subnet. Now, how this integrity and authentication or malicious working of the SDN controller, maybe master or the slave controller, can be done. Normally we are using the BRS, but nowadays blockchain is being used for this work. BRS is an important system. BRS is managing the subnet, maybe single or dual, and handling the backup and related activities. But above all, we are deploying a blockchain, which is a growing list of records called blocks that are linked using cryptography. Each block contains a cryptographic hash of the previous block, which is called a timestamp, and transaction data. That means lifetime is also there. It's an open distributed ledger. It's typically managed by part-to-part network. Let us consider that. You see, this was the architecture with your master slave controller with BRS. So you see, master and slave controllers, under that you have the infrastructure, all the router systems and all the devices are there. So I am putting a blockchain on each subnet or multiple blockchain in a subnet, and we are planning for a two-way authentication. How this two-way authentication? We are generating a hash value. Suppose I am a BRS or a controller. So the hash for the first block will be the decimal value of a. I'm giving some example here. One very simple example I am giving how the hash can be generated in a blockchain based system in your controllers and the BRS. You see, the first hash is a decimal value. I can take as a random number. I am putting into the BRS. Hash for the next is position of the hash value of the first block in the odd even series. I am giving you an example. Yeah, you see, this is one example. You see, I have taken this first, and then the decimal value is 85. This is the first hash value in the first block, or maybe in the BRS. So what is the position 85 in the series of odd number? It is 43rd position. So I am giving 43rd to the next controller. Then 43rd is the 22nd odd. 22nd is the even number. 22nd is the 11th even number. So like this. So I am keeping these as a hash values in various nodes. And I am adopting a two-way authentication. What is my two-way authentication? If you start from the first block in the clockwise direction, and if you start from the anti-clockwise direction, what will happen? In any node, if there is a data or hash, now previous node and the next node, when I compute two data, all will be matched. If it is not matched, there may be a problem in any node. So suppose I am computing, an agent-based program is computing, agent is computing in forward direction and backward directions. If the hash values are matched at each node, then complete network is saved. If it is mismatched in any node, it will be checked from the BRS. It will also be mismatched. That means some attack is there in a controller. So at that moment, the block will be removed. Then another blockchain will be assigned. Even on a timestamp basis, this blockchain may also be reassigned. Now you may say that this is one computation I have shown you, that using odd and even series of the number, and it is a mapping, conceptual mapping. I may use some other algorithm, but that's to make you a conceptualize the things in authentication. I can go for it. The thing is that now on a subnet, I can use multiple blockchain. Not necessarily that I have to use a single. This is the forward computation and the backward chaining computations. So if the value matches with the forward chaining and with the backward chaining, then I can say that the block is secured and the block is correct. No malicious attack is there. So also it will match with the value in the BRS with the computations. Now you see, I can use multiple blockchain for more security. So if I have multiple controller, multiple subnets, so I can use the small blockchains to each other. So problem in any blockchain, I can leave it, then I can put another blockchain. So I can make an interrelated blockchain There may be some intersecting nodes of this block and this block. That means value of this block will be kept. Here also this block will be kept. So that I can go for multi-tier authentication system using a blockchain based system. Now what are the challenges? Because you see still now SDN switches are not available in India. Some switches are coming. Some Kolkata, some institutions, the switches are also coming. Raipur, NIT, they have purchased some switches. But still now there is government policy is not there for SDN switches. Gradually it will be converted to the SDN switches. So there is a complete open space for the SDN research and also for the security in blockchain applications and other security protocol applications on SDN network. So security is both a benefit and concern with the SDN technology. The centralized SDN controller presents a single point of failure and it integrated by an targeted by an attacker, and it may be detrimental to the network. And another challenge is that no established definition of software defined networking in network industry. Now industry standard is also awaiting. That is also another major challenge because these are in nascent stage still now. But lot of IoT based sensor network systems are using this blockchain and this SDN switches. So our future network, the directives of the future network is going towards the software defined network. What are the challenges are there? So some networking initiatives are often mistaken for SDN, including white box networking and other networking. So it has started around 2010-11 when the OpenFlow is initiated. So now what are the summary? The SDN encompasses several types of technologies, including functional separation, network virtualization, automation through programmability, because you are programming the network scenario, you are programming the routing methodology in your network based on your requirement. Suppose I have two faculty, science and arts faculty. If I see that the utilization of the arts faculty of the network is very less, then I can define the traffic in that way. I can define the ports in that way centrally. But now what is available? Then you can go directly to the port by logging into the port, username and password, right click on that, and you go that you can slash down the speed of that port. That means I don't have any centralized control. I don't have any centralized flow of the network. So originally, SDN technology focused solely on the separation of the data plane and control plane. So now we are thinking of how we can write efficient networks protocol for software defined network. Now, what is the benefit of this SDN network? You see, suppose I have a network, perpetual networks, I have defined control plane and data plane separately. I have all programs. Now I need to port this infrastructure to other places. So within a few hours I can shift it. Because architecture will be same, it will be here. I will take the programs and software, I will port into some other network architecture. That is not possible in your normal classical network switch or networking devices. So these are some of the lectures available. Some NPTEL lectures are available. So this is one books by Raj Joins, Introduction to Software Defined Network by Professor Arjwain, and these are some of the web URLs we have used. So these are in nutshell the history and the architecture of the software-defined networks, which is the future upcoming network systems. Thank you. You can have some questions. You can go for question answer session and interaction sessions now. Or
Okay, thank you, sir, for your valuable speech and putting this recent topic to our students. So students who has some questions or any doubts can ask or write in comments or in the chat box.
Yeah. You're always welcome. No questions. No understanding.
I think students doesn't doesn't have any questions.
So I have dealing my.
Okay, sir. Okay, sir. Thank you.
Okay, thank you giving me opportunity
yes,
to share some of my ideas, the new technologies what is coming to share with the students. Thank you very much.
Sir, you have given this time, valuable time to us. Thank you, sir.
সোমেন
স্যার আমি সোমেন বলছি
ছবিটা দেখাও তোমার মুখ দেখতে পাচ্ছি না
স্যার ছবি সে পরে দেখাবো বলছি শুন না আপনি পরে ফোন করবো বলি আপনি খুব সুন্দর টক দিলেন খুব ভালো লাগলো দুর্দান্ত
থ্যাংক ইউ
পরে আপনার সঙ্গে যোগাযোগ করবো নিশ্চয়ই
হ্যাঁ কথা বলো হ্যাঁ ঠিক আছে ভালো থেকো সবাই ভালো থেকো আরো ভালো থেকো বাই টু অল বি সেফ থ্যাংক ইউ
হ্যাঁ স্যার আপনি থ্যাংক ইউ স্যার Okay, we now will call our next speaker. That is my dear friend, Dr. Anabik Pal. So Dr. Anabik Pal probably has joined or not. Let me check first. Okay, just wait for a couple of minutes. So let me check whether he's already in or not. Just wait for 2 minutes. Okay, participants, please wait for a couple of minutes because he is having his tea. Right now it is morning at his place, so just wait for 2 minutes, couple of minutes. Okay, so he'll be joining later. So now let me ask from our students. So students, are you enjoying the sessions? Have you got or have you visualized some new concepts or gained some new knowledges? Are you interested in this topic? Anyone wants to speak can speak. Please speak. What do you feel or how do you enjoy this session?
Hello? Hello?
Yes. It is audible. Okay. The next speaker is one of my dear friend, Dr. Anamik Pal. Anamik is the postdoctoral fellow of National Library of Medicine, National Institute of Health, Maryland, USA. He is working on the development of machine learning algorithms to solve cutting-edge medical image analysis problems. He received the doctoral degree from Indian Statistical Institute, Kolkata. His doctoral research focuses on machine-assisted analysis on skin disease. So now I welcome to Dr. Anamik Pal. So please continue your session.
Thanks for a nice introduction. And today my talk is, okay, can I share my screen?
Yes. There is an option called present now.
Okay.
in the bottom of the panel.
Can you see?
No, it is not visible.
Chrome want to share the contents. Present now. Is it visible?
Yes.
Can you
Now
see?
it is coming.
Okay.
Now it is
Can
coming.
you
Okay.
can you hear me?
Yes, yes, it is visible.
Okay. Okay. So good evening, and now I am responsible to talking about a brief introduction or a preliminary lecture on deep learning for medical image analysis. And in this lecture, I will talking about deep and very basics of the deep learning algorithms, or in superficial level. I am not going to much details or mathematical things, etc., etc. And I will discuss then about the medical image analysis problems. What is the challenge and what are the useful problems people are addressing, and why they are useful for automation on the medical decision making or clinical decision making, etc. And my introduction is already given, so I am not talking much about myself and directly enter into the lectures. I divided this lecture into 3 parts. Firstly, I will talk a basics on deep learning, and then I will talk about something about medical images, what it and where's the challenge for automation and analysis, and what are the things going on for analyzing and medical images. So first, deep learning, and this terminology and this thing is, well, I think that this is one of the well-researched area people are involved in now, and this deep learning is employed for different application areas, popular areas, and among them, one of them is medical image analysis. So deep learning is a branch of machine learning. So firstly, I am explaining what is machine learning. Machine learning is a learning from experience. When knowledge cannot be mathematically expressed or available. Why learning from experience? That means generally the intelligence, we see that the intelligence depends on some if then else conditions and some operation, that is arithmetic and logical operations. But there are less situations are there where we can represent our knowledge with some inference or like if then else conditions. But many problems are there where we cannot, our life is not easy like that. So in that case, we cannot express the mathematically the knowledge. Mathematically, if we place the knowledge, then we can do the, you know that today's computers can do arithmetic and logical operations very efficiently. So if knowledge can be expressed as any arithmetic or logical operation, they can be solved by the today's computers. But many research problems, they are not that much easy, and for that motivation the machine learning is used. Machine learning, which what it is doing, it took some input data and from some data they do some statistical analysis and make prediction map or decision making output. Now what is it here? I am showing the diagram here. Data, from the data some handcrafted features are extracted. These features are basically some statistical computation or some kind of what I can say, some handcrafted or some hand engineered things, which are mainly statistical features, and they are from that the data are compactly represented, and this data representation and expected output are given to the machine learning algorithms, and from that knowledge or inference model is produced. And this is, I can say that in minimally I can say that the machine learning framework is working like that way. Now what is the advantage? It avoids the need for human experts to formally specify all the knowledge that computer needs. So here from data, you are producing a handcrafted features, but you are not involving some if then else rules. So it makes your life easier. Now, what is the disadvantage? The performance depends on the data representation. That means from data to how you produce the data representation or the features, how you convert this. Based on the features, your performance is dependent and highly dependent. So design, if you cannot design well and pretty enough features, then you cannot expect to get a good machine learning model. Now, deep learning. This is a branch of machine learning, and it allows computer to learn from experience and understand the world in terms of hierarchy of concept, where each concept defined through its relation to simpler concepts. Okay, I think that it can be very good explained by mathematical things. Here, in machine learning, we told that our goal is to, from X, we have to infer the Y. So suppose it can be done by writing this f of x equal to y, where f is the machine learning model. But here deep learning, f is decomposed into series set function of function like that. So every, that is f will firstly will be applied a function f1, then will be applied a function f2, and so on and so forth. And there this and finally fn will be applied, and from that a prediction y will be generated. And the model is trained in such a way, firstly initially guess what the f1, f2 and fn will be, and then gradually just doing the error minimization, the prediction model for f is produced. And what will be the block diagram of it? Here raw data and expected output will be given, and learning algorithm will be fitted to a learning algorithm, and knowledge will be produced. What is the difference between that? Here we are not using any handcrafted features. Here the data, raw data is processed in multiple hierarchy or multiple layers, and with the help of the expected output, the inference model is produced. And here some terminology which comes again and again in any deep learning literature, that is the training, validation, and test data. Here we see that we have some, when we are given a data set and their corresponding levels, while we are developing a deep learning models, our task is to evaluate the effectiveness of the model or the performance of the model. And for training data are used to train the model to decide the functions f1, f2, and fn like that. And validation data is used to check whether the model is overfitted or not. And the training, both training data and validation data are employed for during training. And when a very good model is produced by the training and validation data with the help of, then the test data, based on the test data, the performance of the model is evaluated. And in the training phase, lost function optimization is done, because initially I told previously that initially the functional form of the f1, f2 are guessed, and these things are optimized through with the help of the value of the expected value of the y by doing a loss function optimization technique. And in the test page, what I told that performance evaluation is performed. And some popular deep learning algorithms are multi-layer perception here and convolutional neural network. The multi-layer perception accept the raw features or some one-dimensional data and processes multiple layers and generate the prediction map after when it trained. And convolutional neural network, it takes structured data, maybe 2D or 3D or temporal data, and produce the output. And recurrent network deal with some data which have some sequential information or which are sequentially related. And next is autoencoder. Autoencoder is used as a unsupervised learning. That means where your truths or the expected outputs are not known. So autoencoders are used as a unsupervised learning. And next to like generative adversarial model and variational autoencoder, these are used for data generation. The literature for all this topic, all these DL algorithms are very long, so I am not going to much details about those algorithms because it will take much times, but as a general idea, which things will be useful where I am explaining them. So is there any questions up to now? Arup, did you receive any questions up to now?
Please continue your talk. We will take the questions at the end of the session.
Okay, then fine. Okay, this was the introduction about the deep learning and deep learning algorithms and what are the basics things about the deep learning. Now I go into the introduction on medical images. What is it and why medical image analysis is important? Now I will discuss on that. So medical images. Why medical imaging is done? First of all, it helps to understand the anatomy and function of human organ in a better way. Because if we want to inspect our inner body part, we cannot inspect looking outside of the body. So how we get the inner parts informations like lungs or any body organ inside human body. So it will help to understand the both anatomy, that is if the lung is deformed or not, and functions, that means whether the blood is properly passes through the vessels or not, these kinds of things, the functions, both anatomy and functions, they can be analyzed or inspected in better way if we can capture images from them. And next thing is that images can be stored as a health record. The sentence itself is explaining what is it. Health record means how your condition was for a particular organ, and after a time interval what it's become. So from that, the one expert can see that whether this things is deteriorating or this is improving. And third important thing is that images can be utilized for training clinical students. So the disease conditions and the anatomy, those things can be trained by the captured medical images. Now, firstly, I am explain digital images because these things is needed, because so you can get that what is the actual challenge for image analysis. Suppose this is an image, and this image consists of some pixels. The pixel means the smallest part of an image. So as suppose this image has this direction 400 pixels, and this directions there are 300 pixels. So what is there for every facial location? It has 3 different intensities. So if we divide this image into 3 color planes, and we will get these 3 types of things. So every facial position has some intensity values, nothing other than that. For example, the mid part of the 11x11 regions, we have these kinds of numeric values. So to a computer, an image is an stack of 2D or 3D dimensional array of numbers. So here we are saying that color images. So here I am saying that this is a matrix of 3D matrix which contains intensities. Now the range of the intensities will varies, depends on the image encoding. So generally for natural images, this one pixel can get values from 0 to 255. So every position in the pixels can get 0 to 255. So these are the image is generated by the different combination of these numbers. So as a human, you can see that these are the paper images placed on a container, and which is also on the top of a wooden table, etc., etc. But to an automated system, it is nothing but these kinds of numbers on it. So as an image analysis challenge, your task is to do something statistical processing of those numbers and to make a prediction model and identify the object on an unseen data. Now, this was easy for these things was except for the natural images, but for medical images, what it is? Here the thing is that you capture the images based on the how much light is illuminated from the objects. Based on that, these images are captured, which are called optical images. But in case of medical images, our life is not simpler, because while you want to capture a image for a, suppose say lungs or say chest for to analyze the rib cage and nothing like that, so you cannot get images like this way, because these things is not visible to outside body. So you have to go for capturing images for inner part of the body. This is one of the challenges. So without invasive imaging, you cannot do the better diagnosis, because otherwise if you can see the lungs and so your task is over. But without using any invasive things, if you want to see inspect the lungs, so you need some tricky technique to capture the images, or to capture the images which can help to understand the anatomy of the lungs. So different organ and for different function or anatomy analysis, different kinds of imaging techniques or standards are proposed. So we called these imaging techniques are called imaging modalities. Like X-ray, it is well enough. Here what is done? A X-ray rays are projected onto a human part of the object for which the image in the anatomy need to be inspected, and how much it absorbs and how much it passes to the human body. Based on that, the data are encoded in a digital form. Here again also all images will be and the values of with some numbers. And other modalities are computed tomography, 3D imaging, the PET, SPCT, mammography, low-dose X-ray, and MRI. MRI is one of the mostly used. The MRI can be used both for anatomic and analysis anatomy and the functions, and ultrasound, colposcopy, microscopy and colposcopy. These two are optical imaging, because for colposcopy, outer part of the body as images are taken, because this colposcopy is done for the cervical analysis. So here kind of optical images are generated, and microscopy, for that the tissues from the human body are taken away and put under a microscope and images are captured. So here the thing is that we are using some optical imaging technique. And dermoscopy, this is also because dermoscopy is used to capture the images for the to analyze the skin lesions or skin condition. So here the optical imagings are there. So based on the body part which need to be analyzed, different imaging techniques are developed, and whatever technique is that, all cases we will get some number values. So the images may be a 2D, 3D or temporal images. That's when temporal images are needed, like to when you are interested to check the heart, whether it is heart is functioning properly or not, the rhythm of the heart. And 3D images, that is the 3D images means the 3D anatomy of the human brain you are want to inspect. So both 2D, 3D and temporal images are available, can be generated according to now, and both gray and color images can be captured. Gray images, generally the radiology images are gray images generally, and color images, colposcopy images, microscopy images are generally color images, dermoscopy images, etc. So here in case of medical images, first of all, the first task is to capture the images. That means first challenge is that to capture the images. That means how you capture the anatomy of an human body, or what are the imaging techniques you can use. The first decision is like that, and second thing is that how you process them. So how you process them, I am going to now. This is called a medical image analysis. So why it is important? It can be utilized in two different ways. Both. First, it can be utilized to serve as a complement of the medical experts' efforts. So there are places, if an automated system can sieve out the quite obvious cases, then only sophisticated cases can be the experts can focus on the more sophisticated cases more in details. One of the important thing is that, and the next thing is that some cases a human expert cannot do the correct diagnosis, or it may be very difficult to do correct diagnosis, and it may suffer from both inter and inter-observer variations. And in this scenario, an automated system can produce the better disease condition, and it can diagnose in a better way. With these two important aims, the image analysis algorithms are developed. And now I am going into what are the different image classification tasks. Here, means the image classification task means why we are doing third classification. First of all, the classification we do for mainly three purposes: diagnosis, detection, and severity assessment. Diagnosis means given an image, the task is to detect whether a particular disease is present or not. So this takes an image as input, and the class level, that is the whether disease or non-disease, like that output. Second thing is detection. Diagnosis and detection sometimes are same, but there are scenarios where detection is different than the diagnosis. Detection means detecting some clinical features from medical images, like the pigmented network detection in a dermoscopy images, blue-white veil detection in a dermoscopy images. For detection task, if the combining the clinical features, the disease conditions can be seen, but can be decided. But in case of diagnosis as a whole, the diagnosis information can be captured. And another thing is that severity assessment. That is the stage. What is the cancer stage? What is the severity of the prostate cancer? Like that. So severity assessment, that's also can be formulated as a classification problem. While you are using deep learning, mainly people use this convolutional neural network to do this kinds of classification tasks, which takes as input a 2D or 3D images as data matrix, and this image is processed in layer by layer, and finally it produces the prediction probability for different classes. For diagnosis, it may be class versus control. For detection, whether a feature is present or absent, and for severity assessment, the different grade. This is the whole target about the image classification, in the main target of medical image classification. And next thing comes segmentation. Segmentation means to partition an image into meaningful region. Here, in medical image, biopsy images are shown. And this image is taken from internet source, and here three glands are there. This one, this one, this one. Here target is to detect the boundary of detect the glands by automatic way. So what is it? So there are two types of segmentation. One is called semantic segmentation. Here the task is to classify every pixel whether it belongs to a gland pixel or not. So here the outcome, this is a representation, and here we see that these coordinate corresponding to the coordinates corresponding to these pictures is a gland. The coordinate corresponding to this is a gland from here, and this corresponding to a non-gland region here. So here the segmentation task takes an original images and classify every pixels into different object level or different areas. So here the segmentation objective is to segment into glands. And another thing is that to semantic segmentations. Here all objects are considered as same thing, but here all objects are different. So presence of different objects, that means here presence of three different glands are captured individually. That means if two pixels are shown, two locations are taken from here and here, this image, from this kind of segmentation, you cannot say whether these two are belongs to the same object or not. But here, two images, one taken from here and one taken from here, one location, and based on the coordinate, you can say if the algorithm is trained properly that these two locations belongs to the object, our intended object, but different objects. This is called instant segmentation. The semantic segmentation are generally used to segment the anatomy, and it has different utilities. Like first of all, from segmented regions can be analyzed in better way for any classification, prediction, model development. And second thing is that you can compute the size and shape based on the utilizing the semantic segmentations. And you can discard the, you can extract the region of interest from the semantic segmentation using the semantic segmentation. And for instant segmentation, these are mainly useful for counting problem. Suppose given an image, you have to asking that how many glands are there. From here, you cannot count it, this kind of segmentation. But here, as all objects are treated independently or different levels, so you can count it. Suppose you are interested to count the number of WBC in a blood sample images, so you can do it. You want to count number of some abnormal cells in a histopathology, you can count it. So in those kind of segmentation where something related to counting problem, the instant segmentation are done. And some problems where you are interested to differentiate between object and different types of objects and the background, yeah, the semantic segmentations are addressed. So both cases, for semantic segmentation and instant segmentation, both cases, as a input, a deep learning model take the 2D or 3D images and it produces the location wise class map. This model is trained in this way. Now, another popular thing is that image registration. Registration means alignment. It finds the image registration algorithm finds the optical coordinate transformation that best aligns the structure of interest in the input images. What is it? Suppose one image is taken from a human body part, and next time if you want to take the image from the same body part, they may not be aligned in the same way. There may be some rotation, translation, rotation, or some zoomed, etc. So how can we align those two images? The algorithm which is used to align images are called image registration algorithm. Why it is used? It is used to fusion of anatomical images. Suppose from you capture one images, not all areas are clear and you cannot analyze the images from a first images. So you can take the help from the different images which can also improve the quality of the images. So fusion of different modality or same modality can be done to make the anatomical region visible. So or more quality, to improve the quality of the anatomical regions which you are interested to analyze. And the next thing is that atlas building for anatomy comparison. Once the image registration was widely used to develop the atlas for body anatomy, suppose a chest anatomy, rib cage anatomy. So what it will be helping is that you are building different atlas. So looking at the atlas and comparing the atlas, whether say sometimes the chest, the rib cage is there are some any deformed, you can check it. So some geometrical, that is the shape kind of things you can capture. That is atlas building was utilized for that purposes. And the next thing is that anatomy segmentation, because if you have some atlas, from that you have the some geometrical information about the some anatomical region. So with the help of this atlas, a new image can be segmented into the anatomical parts. So these are the main utilities of this. And another important thing is that motion tracking. That is tracking, suppose how the heart is pumping. So if you want to take, you want to see the whether it is in running in proper way or not. So different temporal registration based approaches and the change of the shape, you can track it, and based on that, the whether it is functioning properly or not, you can take decision on that. And here, for image registration purposes, generally two images will be inputted as a deep learning model, and it will predict the transform coefficient, that is scaling, rotation, and translation, etc. parameters from the network. This may be the main task for this image registration task. And it can be also used for computer-aided diagnosis and disease follow-up, reconstruction or enhancement. This is another important part of medical imaging. So one is the denoising, because if in case of medical image generation, there are several sources for noise. So denoising is an important part of the medical imaging. So it will help to better understand the anatomy of the images, anatomy from the images. And next thing is the deep blurring. And deep blurring means the image algorithms which reduce the blurriness from the images. Inpainting means when an image contains some obstacles, where some part are not visible properly. Suppose in chest X-ray, on a chest X-ray, some numbers or some text are written there. So this may help to do some diagnostic information and sometimes some part into a critical area which need to be analyzed. So in that case, inpainting can help to reduce these errors. That means to remove the text and to see the actual anatomy of the from the images. And the next thing is that signal to image conversion. As I told that in many cases, the only signals are generated and they are converted to images from which the decision can be taken. So signal to image conversion is one of the important thing for medical image analysis. And next thing is that synthesis. Synthesis means generation. So image generations. It is an approach which used to model a mapping from given source image to a unknown target images. And what is it? Suppose one image is given, from that you want to generate some different images of the same part. Why it is needed? Because knowledge transform from across modalities. Suppose one CT images is there and another suppose for a medical investigation you need different modalities of images of the same body part, but in some cases some modalities you cannot capture or is not present to now. So from one modality to another modality, if you can transform the images or synthesize the images with the based on the MRI images, if you can synthesize the CT images or vice versa, or you can get the all different modalities of the images. So this kinds of knowledge transformation can be useful for image synthesis by image synthesis algorithms. And another is the image super resolution. Super resolution means increasing the number of pixels. So the general thing is that what you are seeing in your image editor, that a 300 cross 400 images are there and you are increasing by 2x, so the number of pixels is increased. But those kinds of things uses some interpolation like thing, so the image quality is not preserved. So preserving the image quality, how we can increase the number of pixels, that is the dimensionality of the images. This is the task of image super resolution. This is help to better visualization of the small anatomical regions often from the medical images. And it also helpful for annotated dataset creation, especially for segmentation. Nowadays, for deep learning, the annotated dataset is used. Annotated means where you have the ground truth level. So to prepare the segmentation ground truth, if you can synthesize multiple images, so image along with the ground truth can be generated together. So these things can be utilized for annotated dataset generation. Next, other popular areas are content-based image retrieval. This helps. So if you are given an image, it can extract the similar like images from a large repository from the image. This is helpful to characterize. This is helpful for better knowledge representation or for better understanding of the images. Suppose some doctors got an special case which he is not confirmed what the disease is, so he has some confusion. So if he retrieve the similar like images which were stored in the repository, he can easily get an idea or can verify that what he is going to diagnose, whether it is wrong or not, and what are the difference between the images which he is getting and the similar like images. So this helps to better understanding or better diagnosing outcome from manual, and this can also help for training of the medical doctors. And another is quality assessment. Quality assessment means suppose you are getting an medical image, and this may not represent the anatomy or the functional what thing you want to analyze in a proper manner. There may be some noise, or maybe some part is not visible, or image is distorted, or maybe the area or the organ you want to analyze, these things is not visible or not available to you. So assessing them is one of the important tasks for medical image analysis. And the next thing is that multimodal analysis. Multimodal analysis means where you are given multiple images, decision from multiple images, or maybe decision from multimodality images. Modality means what I told previously, that X-ray, CT, etc., etc. So suppose X-ray and CT, based on that you are going to take decisions like that, and maybe some image and some text information, that is image and some text informations are given, or some like what these things is visible like that, some text are given, description about the images are given, and then image is given. From that you are analyzing and make some prediction model. Or sometimes some images and some genomic data are combined together, and analyzing them, some decisions are taken. And these are all about what is going on in the medical image analysis and what are the key tasks there. Now I am talking about the key aspects and challenges. Okay, so what are the key aspects for deep learning based DLMI, deep learning for medical image analysis? First, the data. Here we are saying machine learning means learn from data. So here you need data as well as is ground truth level. So from the data and ground truth level, you have to develop the prediction model. So for deep learning, they are data hungry. Now some algorithms are developed which can cope up with this data requirement, but as much as the data you have, you can develop a better prediction model, because all things are based on the data and the data diversity, and the data how well represent the nature of the different conditions which you want to capture by your prediction model. And the next thing is that hardware. It is the fact that to train these kinds of deep learning models, as you are required a very large number of images or data. So you are training a bigger models. Deep models are not that much easy. The size of the deep models are much higher. So to train it, there is a huge hardware requirement. Generally, GPU are used for solving those things, and you need to develop the optimized architecture. This is one of the aspect, because while you have some models, you have to make the model compressed so that you can deploy it. That means you can use it. Suppose you generate a prediction model and you want to put it into a mobile devices or some handheld devices. So here, after developing the models, your next task will be to compress the model in such a way such that it can use with handheld devices. And for the DLMI, the next thing is that explainability. where I am showing that, explaining the way you see that the model takes the data and develop a prediction model. But how the model is working, which situation it will fails and which situation it will perform well, this kinds of analysis and why this is things, that is the explainability of the models, is an important research issue. And the final issue what need to be addressed, that is the current research work what is going on, is the adversarial attack. Adversarial attack means it has been shown that if a image is given for a well-trained network, it is producing high accuracy for that it will belongs to this class. But it has been shown that adversarial examples can be generated. That means only few pixels can be perturbed and the prediction level can be completely changed in this case. So this is called adversarial attack. So in case of medical images, if you cannot cope up with this adversarial attack, the whole prediction will be changed and it will this will help this may not be useful for clinical decision making, and this will not be helpful for some automated clinical decision making or some diagnosis, those things. So we have to cope up with these kinds of adversarial attack. And the next thing is that some of you are there who are, I think, that who are newer and who want to start your research on some that kind of medical image analysis like things. So as I told that this requires data. So for data, you can you have collaboration. You can collect data from the medical clinic, and otherwise you can collect data from several challenges like Kaggle challenges from Kaggle, and one of the website is that Grand Challenge, and others is that Conference and Workshop challenges. And for those challenge data sets, some images and their prediction level and what you want to get, all things are available. So from that you can make your own prediction models. And that's all for the day. Is there any question?
Any question from student side or any participant?
I cannot hear you properly.
Okay. It's audible.
No, I cannot hear you. Oh, oh, sorry. I am muted.
Okay.
Okay.
Can you hear me now?
Now. Yes.
Okay, thank you very much for nice deep learning and deep intelligence. Thank you very much. I hope students have been benefited. Okay, thank you. Now we have come to the program or session. I will be thankful to all your parents here in admissions. So I hope you all have enjoyed today's session. So we are very much thankful for all the speakers who have given the valuable time to make this webinar more enriched. I would like to thank Honorable Principal Madam for her guidance and constant presence. And I would like to thank organizer members, Dipanita Madam, for her endeavor. And I would like to thank Mr. Anish for the faculty members of the Department of Computer Science for his sincere hard work in all technical aspects to make this webinar and successful. And the last but not the least, I would like to thank all participants from the various colleges and organizations. Thank you very much. Now continue.
Okay.